Welcome to this 2-hour preview of the Modern JavaScript Bootcamp. I'm Andrew Mead, and the goal of this video is to give you a feel for the course before actually enrolling. This is literally the first 2 hours of the class, so you'll get a feel for what we're going to cover and how we're going to cover it. In the description down below, you can find a link to the course landing page. There you can check out the entire course curriculum and explore all of the fun and interesting projects we'll end up building along the way. All right, let's go ahead and jump right in to the preview. Welcome to the Modern JavaScript Bootcamp. I'm Andrew. Thank you so much for joining in. I'm excited to show you everything that JavaScript can do. You're making a very smart choice because JavaScript is currently seeing unprecedented growth. We're seeing growth in the number of people trying to learn the language, the number of jobs available, the salary that a JavaScript developer gets, and the number of places that JavaScript can be used, from the browser to native mobile applications to the server. Now, there are a few goals for this video, a couple of things I want to knock out. I know we're all very excited to get into the course and actually learn the language and start writing and running code, but there are two things I want to cover here. The first thing I want to do is give you a brief overview of how we're going to learn JavaScript, so the curriculum. How are we going to get from where we are now to actually being able to write JavaScript applications? The other thing I want to cover are just a few quick tips and tricks for letting you get the most out of this course, getting the most out of our time together. I'm very excited to jump in, so let's go ahead and talk about how we're going to learn JavaScript. When I was designing and creating this course, I knew I wanted to create a course that was as accessible as possible. JavaScript often gets a bad reputation for being a language that's difficult to learn, but I don't see that. I don't think it needs to be that way. So in this course, we're going to build incrementally on your knowledge, starting with simple features and moving on to much more advanced features. Along the way, there will be a series of challenges requiring you to actually use what you should have learned, and that's going to make sure that by the time you get to the end of the course, you can actually go off and use JavaScript to solve real problems. You can land a job or launch your own application. The course is broken into 3 major parts. In part 1, you're going to learn the very basics of the language. We're also going to install some stuff on your machine that we're going to need for the rest of the course. So you'll learn how to create a JavaScript file, we'll see how we can execute it, and we're going to start using JavaScript to solve interesting problems. In part 1, you'll start building out the to-do and note-taking applications. In part 2, we're going to take what we already know about JavaScript and connect it to the browser. So we're going to tie it up with a user interface so real people can actually use our applications. We'll be able to render stuff to the screen, like the list of notes or the to-dos that haven't been completed, and we're going to figure out how to respond to user interaction. So users can click buttons or submit forms, and we'll be able to do things with that info. This is where we're going to put the finishing touches on the to-do and note-taking applications. In part 3, we're going to start working on the Hangman game as we explore asynchronous programming in JavaScript. This is going to allow us to connect our applications to third-party data sources. So we can send data off to save it, or we can request data, whether it's something like a new puzzle for the Hangman game, a list of all of the countries, a list of movies in the top 200 on IMDb. Being able to connect your application with third-party data sources is essential for creating something real-world. I am super excited to get into all of this, but I do want to continue on with part 2 of this video and just offer up a couple of quick tips and tricks that are going to help you get the most out of this class. The first of 3 tips has to do with you actually writing code. If you just watch the videos in the course and you don't write code, you're going to get to the end of the course and you're not going to know how JavaScript works, and you won't be able to use it to land a job or build an application. And that's not my goal for you. I want you to learn and understand JavaScript, and to do that, you need experience actually writing code and solving problems. So as we explore a new language feature, I'm going to write some code that shows that feature off. We'll talk about the feature and we'll see how it works. It's your job to also write the code and run it when I do. Throughout the course, there are also 80 some odd challenges. This is where I give you a little problem to solve. I then tell you to pause the video and you go off and solve that problem. When you're done, you come back and we work through the solution together. It's essential to actually work through these as well. That's going to give you real hands-on experience solving problems with JavaScript. So when you're done the course and you want to create your own application, you'll actually be able to do that because you'll have real-world experience solving problems on your very own. I would never give you a challenge that covered something we didn't talk about in the course, and the entire course is filmed in real time. It's paced in a way where you can actually follow along. The second thing I'd like to talk about is how you can ask questions. So as you move through the course, you might get stuck. Maybe we install a program together, but when you install it locally on your machine, it doesn't install correctly. Maybe you follow along writing a script out, but when you run it, you don't get the same result I get. Regardless of what's going wrong, you can ask a question in the Q&A to get help. There is a link to the Q&A for each and every lecture at the bottom of the video player. The link is Browse Q&A. There you can browse all of the questions previously asked and answered. You might be able to find a solution to a common problem right away in the previously asked questions. If you can't, that's fine too. You can go ahead and ask a brand new question. All I ask is that you provide as much information as possible. The more information you provide about what's going wrong, the faster I'll be able to get you unstuck and back on track. So if you're getting some sort of error message or other strange output, take a screenshot of your screen and include that with the question. If your code isn't working correctly, go ahead and zip up your project and include that with the question. The more information you can provide me about what you were doing when you saw the error, the better. I'll be able to get you unstuck and back on track real quick. The last piece of advice I have for you is to take your time working through the course. Learning is not a race. It would be very easy to blow through this course in 4 days. I simply stop following along and I skip all the challenges, I watch the videos all day, and I'm done in 4 days. The only problem is that when I'm done, I haven't actually learned anything. That's not my wish for you. For you, it's going to take a bit more time, and that's okay. I recommend coming up with a schedule that works for you. Maybe you can dedicate weekday evenings to the course, or maybe you can dedicate Saturdays and Sunday mornings to learning JavaScript. Whatever it happens to be, try to find a schedule and stick to it. It is truly the slow but steady that are going to win. Now, there are other situations where you might want to think about your pacing as well. If you get really tired and you find yourself skipping challenges or not following along, it's probably a good idea to take a break. Maybe take a day or 2 off. Go ahead and step outside or do something else for a little while. Then when you come back, you'll be recharged and ready to actually learn the language. It's not a race. By the end, my goal for you is to actually learn and understand JavaScript. That might take 3 weeks or 2 months. Either way is good. Let's go ahead and continue on in the next video. The last thing I want to talk about before we dive into the rest of the class is the PDF reference guide that's available with this course. This free 80-page PDF reference guide is designed to serve as your companion as you move through the class. You can grab it as the lecture download for this one, and I recommend taking a moment to do so you have it for the future. It contains notes for every single lecture where we learn something new about JavaScript. It describes what was covered, how that feature works. It also contains documentation links and copy and paste code samples. The goal of this guide is to make learning JavaScript easier. So if you're done the course or you're halfway through, you might forget how something works from 5 or 10 lectures ago. With the reference guide in place, you don't have to go back and dig through the old video. Instead, you can pull up the notes and get a quick gist of what was covered, so you can remember exactly how something worked or why it was important. Now, it's important to note that this reference guide is not an ebook, so it's not designed to be something you can read from front to back to actually learn JavaScript. It's simply a companion to make it easier for you to get through a long video course. I'm very excited to include that for the very first time. With this in place, let's go ahead and jump into the next section and get started with the course. Hello and welcome to Section 2. While 99% of this course is you looking at my screen, the first video for each section is a little section introduction, where we meet up face to face and talk about what we're going to cover in the section. These are super quick, just about a minute total. So here's an example. In this section, you're going to be setting up your machine for the rest of the course. In order to actually write JavaScript code and use the language effectively, there are a few tools we have to install. The good news is that these tools are free and they're available for all operating systems, so you can work through this course on Windows, Linux, or Mac. Any operating system is fine. These tools are going to be essential for actually continuing on with the rest of the course, and by the end of this section, you are going to have written and run your very first simple JavaScript app. So let's go ahead and jump right in. In this video, you're going to install Visual Studio Code on your machine. Visual Studio Code is a text editor. It's not like the text editor on your machine you might use to jot down a few notes. This is one specifically designed for programming languages. So it's going to make it really easy to actually write JavaScript code. This is where we're going to write all the code we write throughout the course. We can learn a bit more about this one, Visual Studio Code, by going to code.visualstudio visualstudio.com. Aside from being my favorite text editor, Visual Studio Code is free, open source, and it runs everywhere. So regardless of what operating system you're using for this course, you are going to be able to install VSC and configure it exactly as I have my local copy set up. For this course, I've actually completely uninstalled all of my plugins, themes, and settings. I deleted Visual Studio Code completely, and we're going to go through the process of setting things up from scratch. We'll start off just by using the default features. VSC comes with JavaScript support, and as we move through the course, we'll add on and customize Visual Studio Code, creating a better development environment. So if you don't have a text editor you already use, or you haven't used VSC before, I'd recommend giving it a try throughout this course, as you'll get the added benefit of being able to set up your local development environment exactly as I have my local development environment set up. If you don't want to use VSC, there are other options out there. In the past, I used Atom. This was a text editor released by GitHub. You could also use Sublime Text, which was a very popular choice in the past. And lastly, there are more complex editors like WebStorm. WebStorm isn't free, but it does come with a heck of a lot of features. It's more of an IDE than a text editor. But for this course, we don't need a lot of those features. I prefer Visual Studio Code. So let's go ahead and actually kick things off by downloading the build. We're going to run through the process of just installing it real quick. Once we're done, we're going to crack it open and make sure it was actually installed successfully. This is where we're going to write all of the code throughout the course, so I'm going to be keeping this program open from basically right now until the final video. Let's go ahead and crack that one open, and the process is going to be a little different for each operating system. I'm going to assume that you are used to installing things, so hopefully you can get through that process without too much trouble. Up here, I have my downloads window. I was just given the application to drag to my applications directory on a Mac. I'm going to do just that. And then all we're going to do is crack it open and make sure it actually works. I'll go into applications, down to Visual Studio Code. I'm going to open that one up. And the first time you open it, you might need to accept some permissions or change some stuff. Mac typically does require some sort of confirmation, like this window right here. And once we click open in that window, we should actually get brought into the program. Right here, what are we seeing? We're seeing the welcome screen for Visual Studio Code. This welcome screen is just trying to guide you through some ways to get started or ways you can customize the program. And we are going to do a little customization right now. What we're going to do is install a couple of plugins that are going to make life a whole lot easier. The first thing we can do is just uncheck this box. We don't need to see this welcome screen every single time we open it up. Over here, this little package icon, this is where we can install new plugins. All of these plugins are going to customize the behavior of VSC in some way. The first one we're going to grab is called Sublime Text Key Map. This plugin is going to switch the keyboard shortcuts for Visual Studio Code from their defaults to the defaults popularized by Sublime Text. While I don't like the Sublime Text editor, I do think they really nailed it with the keyboard shortcuts. This is a super popular plugin. We got about 500,000 downloads. So we're going to go ahead and click install to install this one. Now, in order to actually have this plugin take effect, we have to reload things, but we're going to install one more plugin before we do that. This course is going to be using modern JavaScript from the beginning. And in order to support some of those features, there's just one plugin we have to install. To find this, we're going to search for ES6. We'll talk more about exactly what ES6 is later. For now, the plugin we're looking for is called Babel ES6/ES7, and these are just version numbers, so we're supporting more recent versions of the syntax. This is going to make sure that as we use those new modern features, we're actually able to have a text editor that supports them. Now we can just click install for this one as well, and those are the only two we're going to be using for the moment. For now, we can go ahead and click reload. This is going to completely reload Visual Studio Code, making sure those plugins are actually used. And now it's time to go ahead and move on. Up above, new features are available for Sublime Text Key Map 3. Do you want to enable? Sure. Let's go ahead and do just that. All right, so we have Visual Studio Code all set up. We can go ahead and close down that welcome screen. At this point, it's asking us to open up a new folder for our project. We will do that just a bit later in this section. What we're going to do in the next video is install a program that's actually going to allow us to run JavaScript. We have a place to write JavaScript. Now we need a place to run it. Let's go ahead and jump right into that. As I mentioned in the introduction to the course, one of the great things about JavaScript is that it's a universal language. So once you know it, you can use it in a lot of different places. I can use JavaScript in the browser, on a server. I can use it to make a mobile application, or I can program a virtual reality headset. Whatever you want to do, you can probably do with JavaScript. Now, what does that mean for us? Well, it means that we need to install at least one of those. We need a way to execute JavaScript code, and to do that for now, we're going to be using Node.js. Node.js is typically used to execute JavaScript to create a server, to create a backend for a mobile app or a website. That's not what we're going to use it for. We are just going to use Node to execute basic JavaScript scripts. We're not going to be exploring any Node-specific features. Don't worry, we are going to tie our JavaScript files into the browser a bit later in the course, but that's a more complex process, which requires us to set up HTML, a web server, and a few other things. For now, as we're just trying to learn the basics, that would be a distraction. So we're going to stick with Node as a really easy way to run JavaScript from our computer. We can find that at nodejs.org. Here we can grab the installer, and once again, Node is available for all operating systems. It's free and open source, so regardless of what machine you're using to watch this course, you're going to be able to set it up just like I do. The particular version of Node we install really isn't important because we're not going to be using Node-specific features in this course. We're just using this as a way to run JavaScript files. So as long as we grab version 8 or greater, we're going to be good to go. That means V8, V9, 10, 11, or 12. Right here, I do have a V9 release. I'm going to go ahead and just install this one. Now, the process for installing Node is super simple. It's one of those click next installers. So all we have to do is confirm that we've actually read the terms of service. We have to pick the place to install it. I'm just going to use the default for everything. Then we authenticate, and in about 10 seconds, we'll have Node installed. So we have Visual Studio Code, that is a way to write JavaScript code. We have Node, which is a way to run JavaScript code, which means that we're all set up. These are the only two things we need to install to get a basic development environment configured. I'm going to move the Node installer to the trash, and for now, we're all done. What we're going to do in the next video is to explore a program on your machine called the terminal. It's something that we're going to need to use in order to actually run the files we create. So we're going to mess around with that in the next couple of videos. I'm real excited to get to this stuff. We're actually going to start learning, so let's go ahead and jump right in. Welcome back. This video is for Windows users only. If you're on Windows, there is one more thing you have to install. If you're on a Mac or Linux-based machine, you can go ahead and skip this one and move on to the next one. There's nothing for you here. All right, if you're still watching, I am going to assume that you are on Windows, and what I'm going to do is switch over to a virtual machine. I know this might not be the clearest resolution. I'm only going to be using the virtual machine in this one video. What you need to install is a program called Commander, and you can find that at cmder.net. Commander is a terminal emulator for Windows. So in the next video, we're actually going to explore the terminal and we're going to run some commands from it. If you're on Mac or Linux, you're going to have access to the same set of commands. If you're on Windows, there's a slightly different set of commands. But with a program like Commander, you can actually use the same standardized commands right on your Windows machine. This is a super popular program. It's also similar to Git Bash, which tries to do the exact same thing. All you need to do, though, is install it. In the next video, we'll explore it. So down below, there are two types of installers. There's the mini installer and the full installer. You want to grab the full installation. All this is going to do is download a zip. I have the zip already downloaded and extracted since this virtual machine is really slow. But once you do open up that Commander directory, you're going to have the Commander application. All you have to do is double click it. It's going to crack open a new window that looks just like this. And while it might take a few seconds to start the first time around, in the future it should start pretty quickly. So whenever I open up the terminal on my Mac, like I'm going to do in the next video, you're just going to open up Commander instead. You'll be able to follow along and run the exact same commands. So make sure you do have this program set up. Do take a moment to try to crack it open and make sure you see something like this. Obviously, the details will be a little different, but you should see a black screen where it's asking you to type something in. If you do see this, then you're ready to move on to the next video where we're going to explore some commands we can actually use right inside of here. So stay tuned, and I'll see you next time. Welcome back. In this video, we're all moving together regardless of our operating system, and that's the way we're going to move on throughout the rest of the course. There is no more OS-specific videos. In this one, you're going to learn about the terminal. The terminal is a program on your machine, and it allows you to type commands and issue those commands to the computer. These commands can do all sorts of things. We're going to be using the terminal in the beginning of this course to issue commands to execute the JavaScript files we write. So if we write a JavaScript file that takes two numbers and adds them together, we can issue the command to execute that file and see the result. So that's why this is important. This is how we're actually going to be able to execute the code we run. Let's go ahead and start by cracking this open. Now, if you're already familiar with the terminal, if you're used to using commands like cd to change directories, ls and pwd, you can go ahead and skip this one. There's no new information for you. You can move right over to the next one where we start creating and running our first JavaScript file. If you're not familiar with those commands or you just want a quick refresher, do go ahead and continue on with this one as the information is going to be pretty important. We're going to be using the terminal a lot throughout the entire course. Let's go ahead and crack this open. On a Mac, we're looking for the terminal. On Windows, you're going to use Commander installed in the last video. And if you're on Linux, you're going to use the terminal, the command line, or the command prompt, depending on your distribution. Regardless of what it's called, in the end of the day, it's all the same thing. It is a place to type out commands. We then run the command and we view the output. So let's go ahead and kick things off by issuing our very first command. This one is going to print the version of Node installed on our computers. And that's going to allow us to confirm it was actually installed successfully. So let's go ahead and run this. It is node space -v. This is going to run Node and ask for the version that it's using. Now, how do we run a command once we type it out? Well, we just hit enter. So we hit enter. It issues the command to the computer. The computer does some sort of work depending on what the command does, and then we get an output. Right here, what are we getting? We're getting version 9.3.0, which is indeed correct for me. Your version might look slightly different. As long as the first number is an 8 or greater, you are good to go. So this is just one command we can issue from the command line. Now, your command might have failed if Node didn't install correctly. I can simulate that by just running this command with a typo. Instead of running Node, I'm going to run Node with two E's. I then use space -v like I did above. This command is going to fail, and we're getting some output, command not found. So if you're seeing something like command not found for the correct command without the typo, that means that Node wasn't successfully installed on your machine, and you're going to want to fix that before moving forward. You can open up a new question in the Q&A, and I'll help you get unstuck. If you are seeing Node's version though, we are ready to continue on and learn about another command. This one is super easy. It's called clear. All clear does is it clears the output shown on the screen. So if we run a bunch of commands and we have a whole bunch of output, we might want to get back to a nice clean slate. If I type clear and hit enter, what happens? We have a new command prompt showing up above, and none of the previous commands or their output are visible. Now we can issue other commands. And what I want to talk about is how the commands are actually executed. Every command we run from the terminal runs from a specific directory on our machine. So to visualize this, what we're going to do is crack open the Finder or the File Explorer. In the Finder, I'm always looking at a specific directory. In this case, it's the desktop. In this case, it's my user folder. In this case, it's my downloads directory. So we're always looking at the contents of a specific directory. Well, this is kind of similar in the terminal. In the terminal, the commands we run are always running from a specific directory. And if we don't pick one, it uses our user directory by default. And we can prove this. We can run pwd, which stands for print working directory, and the working directory is just the directory you're currently issuing commands from. We'll talk about how we can switch directories in a little bit. Right here though, if we run pwd, what do we get? We get /users/Andrew. So right here, that directory lines up with this folder. We're viewing the contents of the folder in the Finder. We're able to execute commands from the directory over here in the terminal. Now let's say we do want to execute commands from a different folder. In the Finder, if I wanted to view the contents of a different folder, I would just click the folder, like desktop. I can switch to see what's in there. I can click a different folder to see what's in there. The same thing is true with the terminal. We can use a command to switch the directory we're currently executing commands from. So let's go ahead and switch from the user directory, which I'm currently in over here, to the desktop folder. How do we do that? We use the cd command. CD is short for change directory, and it allows us to switch the folder we're executing commands from. And this is important because when we run our scripts, we're going to have to issue the command from the location where those scripts are stored. We'll talk about that in the next video when we actually set up a folder to store all of the files you're going to be writing in this class. Right here, though, we can switch to the desktop by using cd space followed by the folder we want to switch into. Right here, desktop. Now, if I run that command, what do we get? Well, we get no new output, but if we run pwd again, we can see the working directory has changed. I see users Andrew where I was before, and then desktop. Now we can also go up a directory. So let's say I want to go back to the user folder. To do that, I use cd space ... That goes from the current directory up to the parent directory, which would be switching from desktop back to Andrew. I run cd ... I then run pwd, and what do I get right here? I'm right back where I started from. I'm executing commands once again from the user folder. The last command I want to talk about is ls. ls lists out the contents of the current working directory, so it's similar to how we can see the contents of a folder in the Finder. If I run ls, we can see all of the stuff inside of that folder. Right here, I'm seeing all of the contents of the Andrew directory, which is exactly what I'm seeing over here. I could switch directories to view the contents of a different folder. I could use cd desktop to go back to the desktop. I could use ls, and what do I get? I get the one thing on my desktop, which is a directory called old. So throughout the course, we're going to be using clear to clear the terminal output. We're going to be using pwd to figure out where we're executing commands from. We're going to be using cd to change the location we're executing commands from, and sometimes we'll be using ls to figure out what's inside of the current folder. This is a good time to remind you that there is a PDF companion for this course. It contains information for each and every lecture where we learn something new. For this lecture, it actually lists out all of the commands we just talked about. It tells you exactly what they do and how you can use them. So if you ever forget exactly how things work down the line, you don't have to watch a full video to find the right part. You can usually just refer to that PDF, get the information you need quickly, and then get back to doing whatever you were doing. That's where we're going to stop for this one. We know the very basics of the terminal, but it might not be clear why these are important. We're going to figure out why they're important in the very next video where we create and run our very first JavaScript script. I am really excited to get to that. Let's go ahead and jump right into it. Welcome to the last video for this section. We spent the entire section setting up our computer for the rest of the course. We installed a bunch of tools and configured them, creating a good environment for writing and running JavaScript. So what are we going to do in this one? Well, we're going to test that everything is working by writing and running some JavaScript. To kick things off, what I want to do is create a directory where we can store all of the stuff we create in this course. I'm going to create one on the desktop of my computer, but if you already have a place you store your code, you're more than welcome to put it there. I'm going to put mine right on the desktop, and I'm going to call it JS Boot Camp. And we're going to be putting up a whole bunch of stuff inside of here throughout the course. For now, what we're going to do is create a new folder called Basics. And the basics directory is where we're going to start exploring the basics. So we're going to figure out how the fundamental features of the language works. And in the next section, we'll be adding about a dozen different files inside of here. For now, though, we can go ahead and crack open this folder in both the terminal and Visual Studio Code. We'll add a little bit of code in and we'll run the script. First up, let's navigate to it inside of the terminal. Now I put mine on the desktop and I'm currently inside of the desktop. I can prove that by running pwd. I get users Andrew desktop. If I want to switch over to the basics folder, I use cd to go into JS Bootcamp. Then I use cd again to go into the basics directory. You can actually also chain that command together. So I can go back to directories by not using cd ... but cd ... /.. This is going to bring me up to folders, and I can use cd to navigate into both using one command too. So I'm back on the desktop, cd space JS Bootcamp / basics. Excellent. So I'm in the basics folder inside of the terminal. Let's go ahead and move over to Visual Studio Code. Over here, we're going to go ahead and open up a new directory That's sitting on the desktop inside of JS Bootcamp. We want to open the basics folder. I'm going to crack that open. And now what we're going to see is a view similar to what we'll have for the rest of the course. We have our files and folders over here, and we have the individual contents of the file right here. We don't have any files, so let's go ahead and create our first one. Inside of the basics folder, I'm going to click this icon to add a brand new file, and we're going to call this one hello world.js. All we're going to do is create a one-liner to print out a little message to whoever runs the script. We're not going to talk about the syntax, the characters that make up this line. We're just going to type these characters blindly to test that the environment is indeed working. So for the moment, you're going to follow along with about the next 12 characters. We're going to start off with the word console, which we'll be talking about later in the course. Then we're going to add a dot, the period character, followed by the word log. Now you can see that we're starting to get some syntax highlighting from Visual Studio Code. This is going to break up our code and make it way more readable. And we'll explore more of that in the next section when we actually learn about JavaScript. For now, we're just going to type blindly and ignore why console is green and log is yellow. From here, we're going to open a parenthesis. So that's going to be Shift 9. And you can see that it's automatically closed for us. Inside of here, we're going to open up a single quote. This is also automatically closed for us. And all we're going to do is type hello world. Now, we don't know what this program does. I don't know why there's parentheses, why there's quotes, why there's dots. That's okay. All we want to do is get this stuff typed in the file. We want to save the file, then we want to execute it. We're going to execute it by running a single command from the terminal. Let's kick things off by clearing the terminal with clear. To run the JavaScript file, we're going to be using the node command. It is node space followed by the file name. In this case, that would be hello-world.js. Now, when I hit enter, it's actually going to go off, grab the contents of this script. It is going to run them, and we're going to see the output of the file. If I run the program, what do we get? We get hello world printing as the message for our program. Is this the most useful program in the world? No, but it does at least prove that our environment is all set up so we can work towards actually figuring out what stuff like this does. Now we can go ahead and change this real quick. If I change world over to my first name, Andrew, and toss an exclamation mark at the end, we can save the file and rerun it to see that print instead. Over here, node space, hello-world.js, and what do we get? We get hello Andrew printing to the screen. So throughout the course, we're going to be creating JavaScript files over in Visual Studio Code, and we're going to be executing them over in the terminal. Later on in the course, we'll be executing them in the browser, but this is the setup that we're going to start with. Now it's time to start figuring out exactly what these characters mean, what they do, and how we can use them to do something meaningful. That's all coming up in the next section where we dive into JavaScript basics. I am really excited to get to that, so let's go ahead and jump into it. Hello and welcome to section 3, your very first programming intensive section. In the last section, we got our machine set up, and we actually wrote a single line of JavaScript, but we have no idea exactly how that line works. We used a combination of regular alphanumeric characters with a whole bunch of special characters like the dot and parenthesis without really understanding how they work together. In this section, we're actually going to dive in to the basics of the language. Now, I've spread the basics of JavaScript out across the next several sections, and that's going to give us a lot of time to dive into these fundamental features, which are so important to really grasping the more advanced stuff. Now, as we move through this section and start exploring these features, we're going to see how they fit into real-world applications, and we're going to start getting into our very first challenges, where you're going to need to write code on your own to solve a problem that I outline for you. I am super excited to get started and actually learn the basics of the language, so let's go ahead and jump right in. Welcome to your very first JavaScript video. In this one, we're going to learn about two really important fundamental features of JavaScript, the variable and the string. This is going to get us headed in the right direction. It's going to enable us to explore more and more features and actually figure out how we can write JavaScript and do useful things with it. So to kick things off in this video and in most videos for this section, we're going to create a new file, a new space to explore a specific feature of the language. In this one, I'm going to make a new file right in the basics folder called strings.js. And in here, we're going to mess around with some code where we learn a little bit about variables and strings, and then it'll be challenge time. So what you'll do is complete a task I give you on your own. We'll walk through the solution together. So that's the general flow we're going to follow in these early videos. This is going to make sure that you learn the fundamentals, but that you can also actually use them. That's why the challenges are so important. All right, that's enough intro stuff. Let's go ahead and dive into some code. We're going to talk about the JavaScript variable first. A variable is a way to store a value for later. So we're going to have files that have multiple lines in them. We might want to store a value and access it later in the program. And this could be useful for a ton of different situations. It's such a core feature, we're going to use it in every single script we write. Imagine we're creating an application that allows users to sign up. They enter their email and their password. We store those in variables, and then we can access those values and do meaningful things with them, like check if the email is already used or if the password has a length greater than 9. So let's go ahead and create our first variable, and then it'll be a little easier to see why something like this would actually be useful. To create a variable in JavaScript, we do have to follow the JavaScript syntax for this, and the syntax of the language is just the rules that govern what you can type in a JavaScript file. I can't type anything I want inside of here. We have to follow the language conventions, and that's exactly what we're going to be learning. So as we go through the course and we use these features more and more, you'll get more comfortable writing things inside of your files. For now, though, we're going to start by creating a very simple variable, and the first thing we have to do is type let. Now, let is what's known as a reserved keyword in JavaScript. It's part of the language, and it has a special meaning to it. When JavaScript runs through our files and sees let, it's going to know that we're trying to create a variable. Now we type a space after let, and this is where we name our variable. What are we storing? Are we storing a book title? Are we storing the password? We're storing something, so we have to give it a name. In this case, let's go ahead and actually store our name. So right here, I'm going to name the variable name, N-A-M-E. Now after the variable name, we use the equals sign. So we are letting name equal something. We can actually read that like a sentence. Let name equal, and then right here, this is where we put the value. Now this value could come from anywhere. Later on in the course, we're going to see how a value could come from the user typing something in the browser. We could have it come from a mobile device. We could have it come from pretty much any data source out there. For now though, we're just going to type a static value in. Right here, we're going to create a string. So we've actually already used strings. We used a string over here in Hello World. This thing right here that I have highlighted, this is a string. A string starts with a single quote and ends with a single quote. And what do we put inside? We put inside anything that we like. Inside of here, we can type any characters for whatever we're trying to represent. Maybe I'm trying to represent a book, so I could put something like ego is the enemy, a book on my bookshelf. Maybe I'm trying to represent my name, so I could type my name in, Andrew Mead. And what goes inside of the string doesn't need to conform to any special rules. You can put whatever value you need to store inside of here. So for the moment, let's just stick with this. We're going to put our full name inside of those single quotes. We have our first variable name, whose value is the string Andrew Mead. Let's go ahead and actually do something with it, and we're going to do that down below. We can do it on line 2, but just for the sake of readability, I'm going to add an extra line and do it on line 3, although the code would be exactly the same if I didn't have the extra line. What we're going to do here is just use console.log to print the value to the screen. We're not going to explore the exact details of the console.log and parentheses. We're going to go ahead and cover that in the next section when we talk about JavaScript functions. For now, all we're going to know is that whatever we put inside of those parentheses ends up getting printed to the screen. Later on, instead of just printing things to the terminal, we will actually render things to the browser where the user can see them. But this is going to be a great way to get started with the basics. Right here, let's go ahead and add that. Console.log, we add those parentheses, and we saw that if we put a string inside of there, we got that printing. Well, we already have a string. It's just stored on a variable. So how do we get Andrew Mead to print? We need to reference this variable to get its value. How do we do that? We just type the variable name wherever we want to use it. In our case, we want to use the string right here. So inside of parentheses, I'm just going to type name. Now we can actually run our strings file for the very first time and see what happens. Over in the terminal, that would be node space strings.js. And what do I get when I run this script? I get Andrew Mead printing successfully, and then I get brought back to the command prompt. It's asking me to run another command. So there we have it. We created our very first variable, and this reads like a sentence. Let name equal Andrew Mead. When we print name, we get Andrew Mead. Now that we got the basics down with a simple example, let's explore something slightly more complex. Imagine we had separate variables, one for the first name and one for the last name, and we wanted to combine them to create a full name, which would just be the first name with a space in between and then the last name. How would we get that done? Well, we can explore that by deleting everything in this file and building up from scratch. I'm going to start by creating a first name variable. Let first name equal the string Andrew. Now, for the very first time, the code we've typed in actually doesn't conform to the JavaScript syntax. That's because variable names cannot have a space inside of them. But what I do want to show you is what happens if we were to run the program in its current state, because you might see the screen we're about to see if you make a typo as you're moving through the course. So what I'm going to do is save the file in its broken state, and I'm going to rerun it. Node strings.js. What do I get when I rerun it? I get a really long output with a whole bunch of cryptic characters. So let's go ahead and break this down. This is a JavaScript error. On the very first line of this error, it shows us the exact file that's causing it, strings.js, in my basics folder, in the bootcamp folder on the desktop. And it also shows me the line. It's on line 1. Right here, we get the actual code, our code that's causing the problem, and it's pointing right to name with these little arrows. And then we have the error message down below. Syntax error, unexpected identifier. So our variable name identifier is not valid. It has a space in between. We need to fix that. We can remove this error by just adjusting what it's talking about. We can remove the space, and now we have a valid program. Now, when you do have a variable name with multiple words, it's common convention to use what's known as camel casing. That's where we start off the first letter of each word with a capital letter, except for the first word. So in this case, the first word is first. We leave that lowercase. The next word is name. We uppercase the first letter to make it a little easier to parse with the eyes. And then if we were to have another word like other, name, other, it would look a little bit like this. In our case, though, we're just going to stick with first name since we only need 2 words for the variable name. Now we create last name. Let last name equal the string our last name. And what we're going to do from here is create a variable full name. Let full name equal, what's it going to equal? Well, we want to use values from first name and last name. How do we get a value from a variable? We just reference the variable by its name. So let's start by grabbing first name. From here, we're going to go ahead and actually print full name, and we'll finish off line 3 in just a little bit. Down below, console.log, in parentheses, full name. Now we have a completely valid script, so if I save things, the program should run without printing a really long error message. Right here, I run it, and I get Andrew, which is expected. First name equals Andrew. I then say full name equals first name, which means that full name equals Andrew. I print full name, and I get Andrew. Now, how would I combine those two? Well, let's start by combining them without a space. If you have 2 strings and you want to combine them, you use the plus operator. This is the plus sign. So I have one string on the left plus another string on the right. In this case, on the right, I want last name. This operator is known as the concatenation operator, and that's just a fancy word for saying, hey, put this thing on the end of this thing. We're just combining 2 strings. Now if we run the program, we can see the output of using that concatenation operator. Over here, what do I get? I get Andrew Mead printing, but you notice that there is no space in between. So what we want to do is add a space right in between the W and the M. We can do that by either creating a variable whose value is a space, but we could also just define a string right in line. So right here, I can say first name plus, I can then add a new string, and then I can add plus onto that. Now, what do I want for this new string? Well, I don't want it to be empty. That would result in exactly what we're seeing here. I want a space. So I'll type a space in and save the program. Now full name equals the first name Andrew plus our space plus the last name Mead. And if I were to run the script, we should get what we had earlier in the course. Right here, Andrew space Mead prints to the screen. You should be seeing your first name with a space and then your last name. It's important to notice that we were able to use a combination of inline strings like this one defined right here and variables whose values were strings. So we could have defined Andrew right here instead of first name, the string Andrew, this would work, but the goal was to work with variables, so we referenced first name instead. Both are fine because the inline string Andrew and the variable first name store the exact same value. Now that we've messed around with variables and strings just a little bit, I want to move on to our very first challenge to wrap up this video. All the videos in this course, well, about 90% of them, they're going to have a challenge. This is a time for you to solve a problem on your own using what you learned in the video. So here's how the flow is generally going to go. I'm going to start by setting up the challenge. I'll never tell you to pause the video and solve something without telling you what I want you to do. There's always a very specific goal in mind. After I tell you what I'd like you to do, I'm going to give you a chance to pause the video and go off and do it. That's where you're going to write some code, you're going to run the code and make sure the output works, you're going to experiment, you're going to fix any errors you might have made in your program. This thing might take a little time in the beginning because the mistakes you make are going to be a little harder to solve. But don't get discouraged, because as you work with the language more and as we write more code, you're going to make less errors and you're going to solve those errors quicker than you did in the past. So it's really important to take that time, actually pause the video and try to solve the problem using what you learned. If you can get it, great. If you can't, that's great too. I don't expect perfection. It's all about putting yourself out there and trying to solve the problem. After you're done with your attempt, we're going to go through the solution together. You click play and I'd show you exactly how I would have solved the problem. So let's go ahead and set up our very first challenge. Your job is to use variables, strings, and string concatenation to solve a problem similar to this one. So I'm going to switch over to my text editor and add a quick outline as to what I'd like you to do. You're going to be making three variables: city, country, and location. The city is going to be the string value of your city, and same for country, the string value of your country. Location is going to be a combination of the two. It is going to be the city with the country tacked on to the end and a comma space in between. So I'm in Philadelphia, United States. The final output for me should be Philadelphia, comma space, United States. So we're going to use string concatenation when we create location, just like we use it when we create full name up above. Then the final thing you're going to do is print the location. The end result for my values would be something like this. Your values will look slightly different. So take some time to delete everything in strings.js and try to solve this problem. Create those three variables, use concatenation, and try to print the end result. Take a moment to pause the video, and when you're done, click play. All right, how'd that one go? Hopefully you were able to get things at least started, whether or not they worked successfully. We're just learning the challenge format as well, so it might not have been clear exactly what I expected of you. As we go through more and more challenges, you'll get more into the idea of a challenge. All right, I'm gonna kick things off by creating those three variables. The first one would be city. Let city equal the string with my city, Philadelphia. Then country. Let country equal my country, United States. And then the last variable I wanted you to create was location. Let location, which is a combination of the two with a comma and a space in between. If we want to start with city, I reference city first. If I want to add a comma and a space after city, I use the concatenation operator and I add in the string I want to concatenate on. In this case, comma, space. Now, what do I want to wrap up my string with? The country. So I use the concatenation operator again, and I reference the variable country where I store that string. So I've successfully combined these three strings into one superstring, and then I'm going to print that string out. Console.log, inside of parentheses, whatever we want to print, location, and now we can go ahead and run the program. Over in the terminal, I'm going to use clear to clear the terminal output, node strings.js. Right here, I run the script, I get Philadelphia, United States printing. And there we have it. That is our very first challenge complete. Hopefully you were able to complete that one without too much trouble. The challenges are going to get a bit harder over time. As we learn more about the language, I'll expect more and create slightly more complex challenges. But for now, this was plenty complex as an introduction, our very first one. Don't forget, there is a PDF companion for this course, which contains notes for every single lecture where we learned something. We learned something in this one, so the notes for this lecture talk about creating variables, strings, and string concatenation. There is also a zip download for each lecture, which contains the code we wrote. So if something's not working for some reason, you can always download the exact code I just wrote out, and you can compare it to your code. That is it for this first video. We're going to continue on in the next one by talking about numbers in JavaScript. In this video, you are going to learn about numbers in JavaScript, and this is going to be our second data type. A data type just refers to the different types of data you can work with in a given language. We already learned about the string type right here in strings.js. We're now about to learn about our second type, which is the number type. And that's going to allow us to integrate numeric operations into our program. Imagine we're creating a game and we have a score. We store that score as a number. As people get more points, we can use the addition operator to add those points on. So let's go ahead and create a new place to mess around with numbers. Over inside of the basics directory, I'm going to create numbers.js. And inside of here, we're going to kick things off by creating a new variable. Although instead of giving it a string value, we are going to give it a numeric value. Creating a number is going to look very similar to what we did when we created a string. I'm going to make a variable let num equal. All of this is the same so far. Now right here for the value, instead of using two quotes to create a string, we just type out the number. So if I want num to be the number 34, I type out 34. If I want it to be negative 12, I type out the minus sign followed by 12. If I want it to be 5.5, I type out 5.5. So numbers in JavaScript are super flexible. We can have whole numbers or numbers with decimal places. We can go positive or we can go negative. Let's stick with 5.5 for the moment, and down below, we're just going to log this value, console.log. In parentheses, what are we trying to print to the console? We're trying to print out the value of num. I'm going to save the file and run it from the terminal. Node, numbers.js. Right here, what do we get? We get 5.5. Now this is fine, but it's not particularly interesting. The real usefulness of numbers comes when you can actually perform all of those math operations on them. And all of the core operations are built into the JavaScript language. For example, addition. If I wanted to add something on right here, I could add on 2. Now I would expect 7.5 to print, and if I do rerun the script, that is exactly what we get. We can also use the minus sign between two numbers to subtract two numbers. So let's go ahead and take 5.5 and subtract minus 1. What would be the result? Well, the result should be 6.5. Subtracting a negative is the same as adding. Right here, I rerun the script, and I do get 6.5. So we have addition, we have subtraction. We also have multiplication and division. If I want to multiply two numbers, I use the asterisk, that is Shift 8 on your keyboard. Let's go ahead and take 5.5 and multiply it by 2. The end result, we can save the file, run the script, and right here we get 11. Last up, division. With division, we just use the / on your keyboard. That is just to the right of the period on your keyboard. Right here, we are now dividing 5.5 by 2. What's the result of that? That would be 2.75. If I rerun the script, what do we get? We get 2.75 printing. So we have access to all of these basic arithmetic operations, and that makes numbers in JavaScript really useful. Don't worry, I have outlined all of those 4 operations in the PDF companion for this course. So if you ever forget which symbol is for which, you can always refer to that. Just like we saw with strings, when we are combining various strings, we were able to have some defined in line, and we were able to have others come from variables whose values were strings. And the same thing is true with numbers. We don't have to define all of the numbers in line right here. We could have another variable whose value is a number and reference that. Let's go ahead and mess around with this. On line 1, I'm going to create a variable x, let x equal, I'll pick a value for x like 11. And then down below, we can add a calculation that actually uses the value for x right inside. I could say x plus 1. And then let's say after I perform that addition, I want to multiply it by 2. So right here, we have a slightly more complex little equation. And if we plug in 11, we can get the expected result by running the program. I'll save the file, rerun the script, and what do we get? We get 13. So what's happening here? Well, we have to remember that just like in real life on pencil and paper, the order of operations takes into effect in JavaScript as well. So we have my dear Aunt Sally, multiplication, division, addition, and then subtraction. That means we start with multiplication. We have this right here. 1 times 2 is 2. We then move on to division. Do we have any division? No, we don't. So we skip that. We go on to addition. We take 2, we add 11, getting 13. We go on to subtraction. We don't have any, so we don't actually do any. The end result is 13. We might have been expecting x to get added to 1 first, resulting in 12, then multiplying that by 2, resulting in a much bigger number, 24. To do that, all we have to do is use parentheses to override the order of operations, just like we would on pencil and paper. So right here, I can open a parenthesis, and then I can close one over here. Now we're saying perform this operation first, then use the result to do the rest. So this would result in x plus 1, which would be 12. Then we would multiply that by 2, getting 24. And we can see the different result right here. I rerun the program and we get 24. We were able to go from 13 to 24 just by adding those parentheses into the mix. So as we do work with numbers inside of JavaScript, we're going to be able to perform all of those basic operations, and we're also going to be able to customize the order of operations for the calculations we're creating. Let's go ahead and explore a different example using numbers. I'm going to delete everything we have so far and start with our age represented as a number. So let age equal, and my age is 26. You can go ahead and use yours. What we're going to do is add 1 to our age and then convert it to dog years, where 1 dog year is 7 human years. That's the common ratio between the two. So how would we get that done? Well, we can create a place to store the result right here. Let dog years equal, what is it going to equal? It is going to equal our age plus 1. Let's say we're having a birthday, so we want to add 1 first. Then we want to convert it over to dog years by dividing it by 7, divided by, right here, 7. Now we know because of the order of operations, we're actually going to have 1 divided by 7 happen first, then we're going to add that on to age. That is not what we want. What we want is to add 1 to age first and take that and divide it by 7. So once again, we're just going to wrap this particular part of the equation in parentheses right here. Excellent. Now we are overriding the default order of operations. That is where please excuse my dear Aunt Sally comes into the little lingo. The P being parentheses, those take precedence. Now we can go ahead and actually use dog years. And at the moment, when I say use a variable, the only thing we really know how to do with it is to just print it to the console. So we'll stick with that. Right here, dog years. Let's save the file. I'm going to rerun the script using the up arrow and enter. And right here, I get 3.857 with a whole bunch of decimal places after it. And that is indeed correct. So I'm equivalent to a dog that's about 4 years old. Now, at this point in the course, we're not going to talk about things like limiting the number of decimal places or rounding up or rounding down, though we will cover that a bit later. For now, we're just focusing on the very basics of working with numbers. We'll talk about formatting a bit later in the course when we're actually trying to display things to users, like displaying things in the browser, where we want to have things nicely formatted so the data is clear and actually usable. All right, that is it for our little discussion on numbers. We have access to all of those basic operations, and I've outlined all of the operations as well as included examples of each in the PDF guide for this one. Your job as the challenge for this video is going to be to create a little program that calculates what percent a student got on a test based off of the number of questions they got right and the total number of questions on the exam. For the last challenge, what I did is I opened up a text editor and added some notes inside of there. From here on out, I'm actually going to use JavaScript comments to do that. A comment starts with 2 forward slashes. Everything from there to the end of the line is completely ignored by JavaScript. So I can type in anything I want, quite literally, and it doesn't matter because this is not going to be picked up when we execute the program. I could use this to take notes, to document what I was trying to do, or to talk about a problem I'm trying to solve. We can also put them at the end of lines, so I could put a comment after my console.log saying print the number or whatever would be most useful. We're going to be using comments quite a bit throughout the course, and I'm going to start using them right now to create a little challenge area down below. Challenge area. So down below, what we're going to do is start off with 2 variables whose values are numbers. We're going to have one for the student score, and we're going to have one for the max score. So we have a student score, something like 18, and a max score, something like 20. It's going to be your job to calculate the correct percent. Down below, you're going to have a percent variable, and this is going to store the final output. So for that example, where student score was 18 and max score was 20, I would expect the percent to be a 90%, where each question is worth 5% of your final score. And then your job is to print the percent down here. Print the percent. Excellent. So to calculate the percentage, you're going to take the student score, you're going to divide it by the max score. That's going to give you some sort of decimal. You're going to multiply that by 100. So 18 divided by 20 is 0.9. Multiply that by 100 and you get 90. So you're going to use that formula to calculate percent. Take as much time as you need to get this done. You can delete each comment as you fill out the necessary line. When you are done, do make sure to actually run the program and check that 90 prints for these 2 inputs and mess around with a couple of different values and make sure they work as well. Take a moment to pause the video, and when you're done, click play. All right, how'd that one go? Hopefully you didn't have too much trouble with this challenge. I'm going to start off by creating student score. Right here, let student score equal 18. That's our first number. Now I can go ahead and actually delete that line completely. Excellent. You're more than welcome to leave the comments in place if you want to. Next up, we have max score. Let max score equal. For this test, let's say the max score is 20. So right here, I have max score equal to 20, and I'll delete the comment. The last number we're trying to create, let percent, is where the actual calculation happens. Now I mentioned we needed to take the student score and divide it by the max score. Then we want to take that value and we want to multiply it by 100 to convert the decimal, 0.9 in this example, to the percent, 90. Now in this case, the order of operations does come into effect. We have my dear Aunt Sally, multiplication, then division, which means that max score would get multiplied by 100. And if we ended up dividing student score by that, we would end up with a very, very poor score. So we're not going to do that. We're going to override the order of operations. We perform this calculation first. We take the result, multiply that by 100, and that is what's going to give us our final percent. So now we can delete the final 2 comments and add the last line in. Right here, console.log percent. I'm going to save the program. I'm going to rerun it from the terminal with the up arrow key and enter. Right here we have the output from our first example. Right here we have the output from our new challenge example. We are indeed getting 90 printing. Now I did want you to play around with a couple of other values as well. For example, let's switch this over to a test with 100 questions. So now each question you get right is worth 1 percentage point. And I'll say this student did pretty poorly. I'll give them 41 correct questions. If I were to run this calculation, I would expect 41. Right here, that's exactly what we get. So these 2 values would be the input for the program. And as I mentioned, right now they're getting hard-coded. Later on, we're going to see these come from a different data source. That could be a database, or in our case, it's going to be the user typing some values into a website and submitting a form by clicking a button. For now though, we're still exploring the basics, and we're going to continue doing just that in the very next video, where we're going to talk about a few different edge cases that come up when working with variables in JavaScript. I'm excited to get to that, so let's go ahead and jump right in. In this video, we're going to look at variables in a bit more detail because there are a few things related to variables that, if we don't know, could cause problems with our programs. Let's go ahead and kick things off by creating a brand new file for this one. Inside of basics, I'm going to call this one variables.js, and we are going to kick things off by defining a variable let. I'm going to call this one something like pet name, and we're going to set it equal to our pet name. Mine's Hal. If you don't have a pet, you can just make one up. So we have this variable. What happens if we try to define pet name again? Let pet name. Let's say we want to change it over to a different name, like a dog called Spot. Now we want to print pet name with console.log. In parentheses, pet name. What's going to happen here? Well, this is actually invalid JavaScript. You can't define a variable that you've already defined. Here, I've used let twice to define pet name twice. That is invalid. And we can prove it by running the script. Over in the terminal, node, variables.js. When I run it, once again, we get a really long error message. Now, this error message contains a lot of useful information. We can see that the error is on variables.js line 2. It even shows us the part of the line where the error is occurring, and then we have our message. It's a syntax error. Identifier pet name has already been declared. This is letting us know that we're trying to define pet name, but it's already in use, so we actually can't define that. Now we could call this something else like pet name with 2 E's. That is valid. We now have 2 different variables. But what if we did really want to change the value for pet name? Well, we can do that right here. We can remove that line and replace it with the following. Pet name equals the string Spot. Here we are assigning a new value to the existing variable. I'm not trying to define pet name again. Instead, I'm just assigning it a new value, and this is perfectly valid. So while I can't use let twice to define a variable twice, it's okay to reassign a variable's value later. That's super common. So now our program is going to work as expected. We are going to run the script, and right here I get Spot printing. We start off with the pet name of Hal. I switch it over to Spot, and in the end of the day, when we print it, the value is Spot, and that's what we're seeing. This is the first rule I wanted to explore related to variables in JavaScript. So rule number 1, you can't define a variable more than once. You can define it once, you can change it over time, but I can't use let with the same name twice. The next thing I want to talk about is what makes up the variable name itself. So down below, rule number 2, there are rules related to variable names. This means that you can't use anything you want as a variable name. Let me illustrate with a quick example. Let 3 equal 2. Then let result equal 3 plus 4. What is the end result of this value going to be? Am I going to get 3 plus 4, which is going to be 7, or is it going to try to get the variable 3, whose value is 2, where I would get 2 plus 4, and the result would be 6? JavaScript is not going to be able to figure that out. It doesn't know if you want to use the variable 3 or the number 3, so what it does is it makes numbers invalid as the first character in variable names. JavaScript cannot parse this out. So here are the rules for naming variables. Your variable name has to start with a letter, A through Z, capital or lowercase. It can also start with 2 special characters, the $sign and the underscore. That is it. So letters, $_. After that first character, you can introduce numbers if you like. It just can't be the first character. So a valid variable name could be A followed by the number 1 followed by the $sign. An invalid variable name would be 1 followed by M. The letter would need to come first if you wanted to use a number in a variable name. Another invalid variable name would be test with an exclamation mark. We can't use all symbols in variable names. We can only use the $sign or the underscore character. So keep that in mind as you're naming your variables in JavaScript. It's going to come up over and over again, and it can be a source of confusion early on. Your program might not work for some reason, and it might not be clear why. Just one more rule, and this one is a quick one right here. Number 3, variable names cannot be reserved keywords. So in every language, there are certain words used in the language that have a very special meaning. There are tons of them in JavaScript, and we're going to learn about them as we move through the course. For now, we just know about one, which is let. When we use let, it does something special. This is a reserved keyword. That means we cannot use it as a variable name. So let equal the number 12 is not valid. We cannot use the reserved keyword, though I could change this to let with 2 L's and that would work. It just can't match up with the reserved keyword exactly. You're not going to run into this one too much. It's pretty easy to avoid, especially when you start to drill these into your brain as parts of the language. But I did want to point it out because it is possible that it will come up down the line if you try to create a variable name using something that we haven't talked about just yet. All right, that's where we're going to stop for this one. There is no challenge in this video because the next video is a challenge video where you're going to use everything we've learned so far to create a little temperature converter. I'm really excited to get to that, so let's go ahead and jump right in. Welcome back. In this video, you're going to build a temperature converter. So we'll start off with a temperature in Fahrenheit, and it's going to be your job to convert it over to Celsius and Kelvin, printing both of the converted values to the screen. Let's kick things off by creating a new file for this little project. Right inside of the basics directory, we can call this one tempconversion.js. And in here, we're really only going to need about 5 lines of code to get this done. We're going to create a variable for Fahrenheit. We'll do that part together, Fahrenheit, and we'll start that off at something like 32 degrees. And then it's going to be your job to calculate and print Celsius. So right here, calculate Celsius and store in Celsius variable. And then you will print that value. And you'll do the exact same thing for Kelvin. You will calculate the Kelvin value and store in variable. Last up, print that value. So we're going to be using the Fahrenheit variable in the calculation for both Celsius and Kelvin. So if I were to change Fahrenheit, I would expect the printed output to change as well. When it comes to the actual formula to convert the temperature to Celsius and Kelvin, there are a lot of great websites for that. If we just Google Fahrenheit to Celsius, we can head over to rapidtables.com. They show the formula you can use for converting a temperature in Fahrenheit over to Celsius. This is similar to what we're going to do inside of our program. Obviously, though, this would be where we input the Fahrenheit variable's value. Now, there's also one over here for Fahrenheit to Kelvin that you're going to use for that conversion. And if you scroll down just a little bit, you can test your work with some of these example values. For example, 50 degrees Fahrenheit is 10 degrees Celsius. So let's go ahead and switch back over to Visual Studio Code. And I'll give you the expected output for 32 degrees. 32 degrees in Fahrenheit should be 0 degrees in Celsius and 273.15 in Kelvin. We're not going to worry about rounding those decimal places, so don't worry if those are off at the moment. Take as much time as you need to get this one done. Run the calculations, print the values. When you're done, test your work. Make sure it actually does work, and then tweak the Fahrenheit value and make sure the other values change as expected. All right, pause the video, and when you're done, click play. All right, how'd that one go? Hopefully you were able to convert the temperature and get it showing up in the terminal. I'm going to go ahead and kick things off by converting the Celsius temperature. I'm going to delete these 2 comments and add the code right in here. Let Celsius equal, then right here, what are we going to set it equal to? We are going to set it equal to this formula. So we take the temperature in Fahrenheit, we subtract 32, we multiply that by 5 divided by 9. Over here, take the temperature in Fahrenheit, we subtract 32, then what do? We multiply it by 5 divided by 9. Excellent. So that is going to be the correct conversion for Celsius. Now we can go ahead and print that, or we can move on and calculate Kelvin first. And that's what I'm going to do. So let Kelvin equal, and then you needed to go over to that page, Fahrenheit to Kelvin, to get that formula. Right here, we take the temperature in Fahrenheit, we add 459.67, and then we multiply it by the exact same thing we did for Celsius. So let's go ahead and use this formula. Let's see if I can remember that. 45967. Over here, we take the temperature in Fahrenheit, and we subtract, add, right? Add? Yes, add 45967. Then what do? Well, we take that result and we multiply it by 5/9, exactly like we did for Celsius. Now what do we have? Well, we have the converted values, and the last thing I wanted you to do was just to print both to the screen. And you should have used console.log for both of those. Right here, we will print out Celsius. And then we can add another one down below, console.log, in parentheses, we will print out the value of Kelvin. And there we have it. This is the final program based off of what I wanted you to do. Once again, it's okay if you might have done things slightly differently. Maybe you logged out the Celsius variable before creating the Kelvin one, and then you logged that out after. That's totally cool. The details aren't particularly important. What is important is that you were able to solve the challenge using the big picture stuff, creating the 3 variables and logging both out. Let's go ahead and test our own work by actually running the script. I'm going to switch over to the terminal. I'm going to run it node temp-conversion.js. When I run the script, what do I get for Celsius? I get 0. That is correct. What do I get for Kelvin? I get 273.15, which is indeed correct. I'm going to test this out with one more value. Let's switch 32 degrees Fahrenheit to the more temperate 50 degrees Fahrenheit. Still pretty chilly. We'll rerun the script. And right here, we get 10 degrees for Celsius and 283.15 for Fahrenheit. It's currently about 11 degrees outside, and there's about a half a foot of snow on the ground, so I would take either of those 2 temperatures over the reality right now. All right, with this in place, our temperature converter is all done for the moment, but don't worry, we're going to expand on this little project as we learn more about what JavaScript can do. We're going to continue working with JavaScript in the next video. I'm excited to get to it, so let's jump right in. So far, all of these scripts we've written run from top to bottom, executing every single line. For temp conversion, we start with line 1, then we go to 2, 3, 4, 5, and 6, and then the program is done. But what if we wanted to do something only under a certain condition? For example, what if we wanted to print a message that it's freezing outside, but only when the temperature is actually 32 degrees or lower? For Celsius, that would be 0 degrees or lower. Well, currently, we do not have a way to do that. There is no way to conditionally run some code based off of what we know, but we're going to get into that in the next couple of videos. In this one, we're going to start exploring that topic by learning about our third data type. We have strings, we have numbers. In this one, we're going to learn about Booleans. Let's go ahead and create a new file to mess around with these. In here, Boolean, Boolean.js, and we're going to start by creating a new variable and setting its value equal to a Boolean. I'll stick with the is freezing example, equal. Now for strings, we type some quotes and we put some stuff inside. For numbers, we just start typing out our number. For Booleans, we have 2 potential values, the Boolean true, where we just type out true, or the Boolean false, where we type out false. That is it. Now, this is actually a really useful data type because think about a lot of different situations where you have something that either is or is not. Is the password valid? It's either valid or it's not. Is it freezing outside? It's either freezing or it's not. There is no third state. It's either yes, no, on, off, true, or false. So we're going to be using Booleans a lot, especially when it comes down to creating programs that do something conditionally. Now, before we continue on, let's go ahead and console.log is freezing, and just get this value printing to the screen. Over inside of the terminal, we can run this one, node boolean.js, and when I run it, what do I get? I see false printing. If the value was true, I would have seen true printing. Now, in most situations, we're not going to type out a static Boolean value. We might, for example, get some input from the user, and then we would use a comparison operator. Comparison operators are going to allow us to see if two things are, for example, the same, or if one number is greater than another number. There are 6 main ones, and I do want to take a moment to explore those. So right here, let's create a variable. Let temp equal, and I'm going to stick with 31 degrees Fahrenheit, where 32 degrees is the freezing cutoff. Now we could imagine that the temperature comes from the user, and instead of just having the static Boolean here, we're going to use one of our conditional operators to generate a Boolean. So isFreezing is still going to be true or false, but we'll be generating it based off of some operator. And we're going to start with the simplest and most common one, the equality operator. Are these two things equal? Right here, let's go ahead and play with that. This is, first up, a reference to temperature. I'm trying to check if the value stored in temperature equals something else. Now, after a space, we add the equality operator. This is 3 equal signs in a row. 1, 2, 3. So on the left-hand side, we have value 1. We have our 3 equal signs. On the right-hand side, we have the other value. Let's go ahead and stick with 31. So is this value stored in temperature equal to the value 31? And the answer is yes, they're both the number 31. The end result is that isFreezing is still a Boolean. It's the Boolean true based off of this comparison. Now we can save the program and rerun things from the terminal. What do I get? Right here, I get true printing. We could see this switch to false by switching up one of the values. Let's go ahead and check if the temperature is equal to 32. 31 is not equal to 32, so if I did rerun the program, what do we get? We get false. So this is the first operator, and I'm going to make a little note of this up above. In a comment, triple equals is the equality operator. Now we have the equality operator, but we also have the opposite of that, where we can check if two things are not equal. That looks a little different. We can keep temp and 32 exactly the same. I'm just going to delete the 3 equal signs and replace it with an exclamation mark followed by 2 equal signs. This is going to return true if the thing on the left and the thing on the right are not equal. Are they equal? They are not, so I would expect isFreezing to be true. If I run the program, this is exactly what I get. We're getting isFreezing having a value of true, which is correct based off of the conditional logic we've set up above. So that is our second one right here. Exclamation mark, 2 equals. This is the not equal operator. Now, these can be used for all data types. So if I had string values up here, like the string Andrew, I could check if it's equal to something else. Let me go ahead and switch back to the equality operator and type in the string Andrew here. Are they equal? Yes, they are. And once again, we will see the Boolean value true print if we save the file and run the program. Now, if the values were different, like if I added a space at the end of the W in the string, this is going to result in false for the Boolean value because they are not equal. They share some of the same characters, but not all of the same characters. So running the script is going to result in false. So we're going to be using the equality operator and the not equal operator for a lot of different data types, but for numbers, we have another set of comparison operators we can use. Let's go ahead and switch temp back over to a number. I will stick with 31. Down below, we're going to still reference temp. I'm just going to remove the current operator as well as the string Andrew. Let's go ahead and kick things off with less than or greater than. To make a less than comparison, we use the less than symbol on your keyboard. That is Shift followed by the key just to the right of your M key. Then on the right-hand side of this, we put the other value. So isFreezing can be calculated using something like this. Is the temperature less than 32 degrees? If it is less than 32 degrees, we'll have the Boolean true right here. If it's not, we'll have the Boolean false. Based off of this data, what would we expect? I would expect it to be true, and it is indeed true. If I switched it up to 32, I would expect it to be false. Since temp is not less than 32, they're equal. I rerun the script, and that is exactly what I get. So right here, we can outline this third one. Less than operator. Excellent. Now there is a less than operator. There's also a greater than operator, which is just the other symbol right here. This is shift followed by the period key. And what do we get? Now we get a greater than comparison. Is the temperature greater than 32? Once again, it's not. They are equal. But if I did switch it over to something like 100, it would indeed be greater, and I would get the Boolean true printing. So let's go ahead and outline this one as well. Right up here, greater than operator. Now we have greater than, we have less than, we also have greater than and equal to, or less than and equal to, right here. To do that, I just put an equal sign after the first symbol. So this would be greater than or equal to, and this would be less than or equal to. And this is a little more like the temperature comparison we want to set up. Now, if it is 32 degrees, we are going to get the Boolean true. Well, 32 is not less than 32. They are indeed equal. And this comparison operator is going to catch that edge case. So we can go ahead and run the script. And what previously returned false now returns true. So let's go ahead and make a note of those two as well. Right here, less than followed by the equal sign, less than or equal to operator. And the final one is greater than or equal to. Greater than or equal to operator. Excellent. So these are the main 6 operators that we're going to be using to set up conditional logic inside of our JavaScript applications. At this point, we just know how to generate these Booleans. We don't know how to actually do something dynamic based off of its value, and that's okay. Let's go ahead and wrap this one up with a little challenge, and we'll explore that topic in the next one. Challenge area. Imagine we're creating software for an amusement park, and we want to offer discounts to people who fall under certain age ranges. For example, if you're under 7, we'll call you a child, and we'll say that you can get in at a discount. If you're over 65, we'll say you're a senior, and you can also get in at a discount. And everyone else will just get blanketed in at some sort of standard rate. Well, we can use our comparison operators and use someone's age to figure out if they are a child or if they are a senior. So right here, you're going to use 5 lines to get that done. First up, create an age variable set to your age. So we're going to start off with an age variable as the basis for our calculation, just like we start off with a temp variable up above. Then you are going to calculate is child. And that's going to be if they are 7 or under. Then you are going to calculate is senior. If they are 65 or older. And then finally, you're just going to print both to the screen right here. Print is child value, and then print is senior value. So we're going to have a few variable creation lines up above and a couple of console.logs down below, following a similar format as we used up here, just with a different set of data and a different set of comparison operators. So take some time to knock this one out and then plug in some sample data. If the age was 7, I would expect is child to be true and is senior to be false. If the age was 30, I would expect both to be false. And if the age was 65, I would expect is child to be false and is senior to be true. Take as much time as you need to knock this one out, test your work, and when you're done, click play. Welcome back. How'd that one go? Hopefully you were able to get it done. Let's start by creating age. Let age equal your age. Mine's 26, so I'll put that right in there. Then we're going to move on to the calculation, figuring out if based off of that age, the person is a child. So right here, I will create a variable. Let is child equal, and then we're going to set up the comparison operator of choice. In this case, it would be less than or equal to. So is the age less than or equal to 7? If so, we're going to qualify them as a child. If not, we're not going to qualify them as a child. That is it for is child. We can move on to the next one, which is senior. Is this individual 65 or older? Let is senior equal, and then we're going to set up the comparison operator. Is the age greater than or equal to 65? If so, they are a senior. The final thing we wanted to do was to just test our work by printing the values to the screen. Console.log right here is child. Then down below that, the final line for the script, console.log in parentheses, printing is senior to the console. Now we can go ahead and actually save the program and test our work. With an age of 26, I would expect both of these to be false. Over here, I'm going to use clear to clear the terminal output. Then I'm going to rerun the script. Node boolean.js. When I run it, what do I see? I see that isChild is not defined. So right here, it's pointing to the exact place where I made a mistake in my program. Now I could go back and refilm this and pretend I don't make mistakes, but typos are part of software development. So when I see this, I can realize that C isn't capitalized, even though I'm pretty sure I made it capitalized. I did, so all I have to do is fix it down below. Excellent. Now we can try again. I'll clear the terminal output and rerun the script by using the up arrow key twice to get to the command I ran 2 commands ago. I hit enter and we get false and false for isChild and isSenior. Now let's tweak that value. I'm going to set it equal to 1, in which case I would be a child and I wouldn't be a senior. That is exactly what I get over here. True, then false. And the final thing I want to test is my isSenior calculation. Let's use 65, which would qualify you as a senior based off of these values. And right here, we get false for child and true for senior. So there we have it. We now know how to create Boolean variables. We also know how to use comparison operators to generate Boolean values. With all of this in place, in the next one, we're going to figure out how to actually do something conditionally in our program based off of these Booleans. I'm really excited to get to that. So let's go ahead and jump right in. And now that you know a bit about Booleans and our comparison operators, in this video, you're going to learn about the if statement, which is going to allow you to conditionally run some code. So if some condition, execute some code. And to kick things off, we're going to bring it back to the example I brought up in the beginning of the last video. It's freezing outside and I want to print a message letting you know. I already know whether or not it's freezing. This is either true or false, depending on whether it's freezing or not freezing. But how do I actually conditionally run some code? Well, we can mess around with that. What we're going to do right here is remove the console.log and add in an if statement instead. Now, much like defining a variable with a value using let, we have to follow a specific set of rules, the JavaScript syntax for creating a valid if statement. And it all starts with the if keyword. After the if keyword, we're going to type a space, and there are 2 things we have to provide. We have to provide the condition, and we have to provide the code to run if the condition is satisfied. So the condition would be whether or not it's freezing outside, and the code to run would just be the message that says it is freezing outside. Now to set up the bare bones if statement, we're going to have if space, then we're going to open and close some parentheses. We'll put something inside of there in just a second, then another space, and we are going to open and close a set of curly braces. And right here inside of the curly braces, we're going to hit enter. And this is the bare bones structure we're going to be using. The condition goes right here in the parentheses. The code to run goes right here in the curly braces. Let's go ahead and set up the condition first. So in the end of the day, the value that we put inside of here is going to be a Boolean. If we type in the Boolean true, this code in curly braces will always run. If we type in the Boolean false, the code will never run. In our case, we have a Boolean, but we're not going to type true or false right in here. We're going to reference is freezing, which is indeed a Boolean. We printed it in the last video and we saw it was. So right here is freezing. Now our if statement is going to check if is freezing is true. If it is, we're going to run this code. If it's not, we will not execute the code. Currently, there is no code inside of there, so let's add some. What we have here is called a code block. There are a lot of different ways we can create code blocks in JavaScript. An if statement is just one of them. This is a place where we can put as many lines of code as we like. I could create variables. I could add other if statements. I could go off and do other things using JavaScript that we haven't explored just yet. For now, though, let's just use something we already know about. Console.log. I'm going to print a string. It is freezing outside! Exclamation mark. Now, we typically nest our code blocks for readability. This code is perfectly valid, but if you use an automatic formatter, which we'll look at in a little bit, or you read anyone else's JavaScript code on the web, you're going to see something like this, where they use a tab or a set of spaces before each line in the code block. This makes things a lot easier to read when you're scanning a file. If freezing, run this code, it's easy to parse that out. So there we have it, our very first if statement. Let's go ahead and run it and make sure it actually works. Now with the temperature value of 32, I would expect the message to print. 32 is indeed less than or equal to 32. I'm going to save the file and over here, run it. Node boolean.js. When I run the file, what do I get? I get my message. It is freezing outside. Now let's change the temperature to not be freezing. I'll change it to a nice 80 degrees, save the file, and rerun things. This time around, I would expect to not see this message. I would just expect to see the two booleans from the example down below. I'm going to rerun the program, and that is exactly what I get. So using an if statement, we were able to conditionally set up some code to run in JavaScript. And this is going to be super important in every single program we write. This is known as flow control. We're controlling the flow of our program using a series of if statements and conditions. So we're not always going to run the code inside of here, but sometimes we will. Now you can add as many if statements as you like, and we can actually simplify this one before adding a second one. What we have right here is a reference to isFreezing. IsFreezing is used only one time, and we have our comparison operator sitting right here. We can actually move the comparison operator into the parentheses and get rid of the need for isFreezing altogether. Right here, I can add the comparison operator in temp less than or equal to 32. I can then remove the isFreezing variable from above. This setup is exactly the same as the code I had just a few moments ago. In this case, we're just setting up the condition right inside. We know that it resolves to either true or false, so we're still passing true or false into parentheses, which is what the if statement needs. Now that we have one that prints when it's freezing, let's go ahead and add a second one together that prints when it's super, super hot out. Let's say if it's above 110 degrees, we want to let you know that you might want to consider not going outside. Right here, if. After if, we set up our parentheses. After the parentheses, we set up our curly braces and hit enter, and then we can start filling things out. What's the condition? Well, the condition is going to depend on the temperature. So temp. Is the temp greater than or equal to 110 degrees? 110. If it is, we are going to print a message. I'm going to indent and use console.log to print a new message. It is way too hot outside. Now I could add other lines on right here. In this case, we just happen to need one line for each, but to prove it, I could hit enter and use console.log to print testing 1, 2, 3. Now let's go ahead and see what happens. If I were to run the program with the second if statement in place, I would expect neither message to print since 80 doesn't satisfy either of those conditions. Over in the terminal, whoops, there we go. What do I get? I get no message printing, which is correct. Now let's tweak that value. Up above, I'm going to move 80 to 180, which should indeed print the it's way too hot outside message. I'll rerun the script. And right here, I get it's way too hot outside. I also get my second log, testing 1, 2, 3, and then I get my two booleans from the example down below. Using if statements, we're going to be able to create complex programs. We're going to be able to insert things like validation, show an error message to the browser if the user's password has less than 9 characters, and things along that line. For the moment, what we're doing is not too crazy, but it's important to get the basics of the if statement down before we move on to more complex examples. Now that we have 2 examples in place, let's wrap up this video by introducing a little challenge requiring you to use if statements. We're going to continue building off of the example we set up down below, although we are going to delete all of these lines. The only thing we're going to leave in place is the age. You're going to set up an if statement for the children and the senior citizens and conditionally print a message for them. So right here, we have the age. I'll leave a little comment. If 7 or under, print message about child pricing. And you can print whatever you want for the message. You could say you're going to get the child's discount or something like that. Then you're going to have a separate one. If 65 or older, print message about the senior discount. And for this one, once again, the actual message itself isn't particularly important. You can just say something like you're going to get the senior citizens discount. So take some time to fill out both of those if statements and then test your work. With an age of 65, I would expect to see the senior citizen discount message, and then we can tweak it to a couple other ages and make sure all of the other cases work as well. Take some time to pause the video, knock this one out, test your work, and when you're done, come back and click play. All right, how'd that one go? I'm going to kick things off by creating the if statement right here for child pricing. If my parentheses my curly braces, let's move into the condition. What exactly are we trying to check? Well, I'm going to use the less than or equal to comparison operator to see if they are less than or equal to 7. Right here, age less than or equal to 7. If they are, I do want to let them know about that child pricing. So console.log, you will get a child discount or any other message that seems appropriate. That is the first if statement. The second one down below that is going to be to check if they are a senior. If our condition, our code block. What's the condition here? Well, we are going to use our greater than or equal to comparison operator. If the age is greater than or equal to 65, what are we going to do? We're going to print a message. Console.log, you will get, whoops, make sure to toss that inside of quotes, you will get a senior discount. Excellent. The last thing left to do was to test your work. I can test this out by running the program after saving it. Right here, I would expect the senior discount message to print. I do indeed get that. Let's tweak the age to something like 64, which does not justify either of the discounts. I rerun the script, I get no second message, and then I'm going to switch it to a much younger age. Let's go with 6, which should get the child discount, and if I rerun it, this is exactly what we get. You will get a child discount prints. If statements are going to be a critical part of all of the real-world applications we end up building, since conditional programming is essential to doing anything meaningful. In the next video, we're going to take a deeper look at if statements. There are a few other things I want to explore, how we can add on other clauses to, for example, do something when a condition is not met. I'm really excited to get to that, so let's go ahead and jump right in. In this video, we're going to continue to learn about the if statement. There is a bit more to it than what we've covered so far. To mess around with this, let's create a brand new file in the basics directory, and I'm going to call this one boolean-advanced.js. For this example, let's start off with a variable is account locked. And let's pretend we're making some sort of account management software, and we'll set it equal to true. So for this particular user, the account is indeed locked. This data might come back from a database or somewhere else. Now, if we wanted to print a message when the account is locked, we know how to do that. If right here is account locked, we then, inside of curly braces, set up the message we want to print. Console.log is account locked. Awesome. Now, what if the account isn't locked? Right now, we don't have a way to get that done. We know that if this condition is true, this code runs. If the condition is not true, this code doesn't run. But with if statements, we actually have the ability to add on an optional else clause. That lets us provide some code to execute if the condition is false. So in this case, to create an else clause, we would, right after the closing curly brace, type else, followed by another set of curly braces, creating another code block. So if the condition is true, run this code block, otherwise run this code block. And as I mentioned, else is completely optional. We created plenty of completely valid if statements without using else at all. In here, we can now do something when the account is not locked. Console.log, welcome, for example, welcoming the user whose account is indeed unlocked. Let's go ahead and test our work. Over in the terminal, we can run this brand new file, node boolean-advanced.js. When I run the script, I get account is locked, which is indeed expected since this is true. Let's switch it over to false and see what we get. I'm going to save the script, rerun it, and we get welcome. Using the else clause, we're going to be able to provide a fallback. So if the condition doesn't pass, we're going to have the option to do something else entirely. Now, once again, not all of your if statements are going to justify an else clause, but there are a lot of situations where we either want to do one thing or another thing. And with if else, we can get that done. There is one more optional clause we can add into our if statements. Right now we have the regular if statement, we have the optional else clause, there's also the optional else if clause. And to figure out why something like that would be useful, let's look at the following example. Based off of this code, only one of these code blocks will ever run, but one will always run. That means that we're never going to have neither of these messages print, but we're also never going to have both of them print. Now this allows us to go down two different roads. We can go down road A, or we can go down road B. But what if there was three different roads we might want to go down? What if we might want to go down A, we might want to go down B, or we might want to go down C? Well, using what we already know, we don't have a way to get that done. To talk about why that is, let's go ahead and introduce a second variable into the mix. Let user role. And let's say that user role is just a string and it stores the user's role. We either have a generic user or we have someone with special privileges, and for them, we'll have a user role of admin. And now imagine the application we're creating is going to show these messages to the user in the browser, for example. We might want to show them is account locked. We might want to show them welcome, but for admins, we want to show them welcome admin. Right now, there is no way to get that done. Yes, we could add another if statement down below, but that's completely irrelevant because one of the two pieces of code above are going to run no matter what, which means that best case scenario, we get two messages printing, and that's not what we want. So there is nothing we can do down below to prevent either of these from running. What we're going to do instead is use the else if clause. So let's take a look at that in isolation, and then we'll integrate it up above to this real example. It starts off with an if statement, like always, and we put our condition in. For simplicity's sake, we're just going to stick with actual typed out Booleans. So in this case, let's say true. What do we know about this? We know this code will always run. Now let's integrate a second road right here, else. What do we know about this? We know this code will never run because of the condition specified up above. To add an else if, we put it right here after the if and before the else. So that looks a little bit like this. I'm going to type in else, if, I'm going to add some parentheses, and I'm going to add some curly braces. Now, right inside of these curly braces, I'm going to hit enter, and this is the structure for an if statement that also has an else if condition. What do we put inside of these parentheses? We put in our other condition. For now, let's go ahead and say it's true. Now that we have an else if and an else, we have three roads we can go down, road A, road B, and road C. Based off of these values, which road are we going to pick? We're going to go down A. Once we find the first passing condition, we stop. This one passes, this code runs, the other two pieces of code never run. If this was false, we would check this condition, it wouldn't run, so we would check this condition. This condition would run, and we would go down road B. And in the final scenario, both of these conditions would be false. So we check this condition, it's false, this code doesn't run. We check this condition, it's false, this code doesn't run. Finally, we have else, and that allows us to go down one of three roads. This is going to fix the problem that we just explored up above. Now, it's important to note that you can use else if. They're both completely optional, which means that I could use else if without else if I wanted to. This is a perfectly valid if statement, and we'll see situations later in the course where it makes sense to use something like that. For the moment, though, let's go ahead and stick with all three. So what's the first thing we're going to check? Well, we are trying to split between those two greetings, but we're always going to print the same message if their account is locked. So let's start there. Is the account locked? If the account is locked, we don't care about anything else. We're going to print the message and print nothing else. And we already have that message. So we can just take this line, copy it, and paste it right in. Next up, what are we going to put inside of here? Well, in here, we're going to check the user role using the equality operator. So is the user role equal to, using triple equals, the string admin? If it is, great, this code will run. If it's not, that's fine too. We'll move on to the else clause where we have the generic greeting. So right inside of here, console.log, welcome admin. Now down below, inside of else, console.log welcome. Now we have one of three roads we're going to go down. One of these is always going to run, but only one. We're never going to have 0 run. We're never going to have 2 or 3 run. We can delete the old if statement from up above, and we can actually test our work. So with the current data, the account isn't locked, but they are an admin. So I would expect welcome admin to print. I can rerun the script, and that is exactly what I get. Let's go ahead and change the user role over to user. Now this condition is going to be false. It'll continue down to the generic greeting, and if I rerun the script, once again, I do get welcome. So using the optional else and else if clauses, we can create more complex conditionals in our programs. And now let's create a more advanced version of our little temperature warning app over here. In this case, we say it's freezing outside. In this case, we say it's way too hot outside, but what if it's right in the middle? Then it's probably pretty fine to go outside as long as you got maybe a jacket or a t-shirt. So let's add in a third row where we say it's fine, go outside. That's what you're going to do over here as the challenge for this video. Down below, I'll create a little challenge area. And you are going to start with a temp variable, which I will give you. 45 would be a good medium temperature. And you're going to have one of three situations occur. 3 different messages, only one's ever going to print. It's freezing outside. It's hot outside. Or the final one, go for it. It is pretty nice. So we want to set up an if statement with an else if and else clause to make sure we hit all 3 scenarios. It's going to be your job to actually create this if statement with else if and else, and then test your work. For a temperature of 45, I would expect go for it. It's pretty nice out to print. If it was 31, I would expect it's freezing outside. If it was 120, I would expect it's hot outside. Take some time to create this if statement and then test your work. Run the program, switch around the value, and make sure you see the different message as the value changes. All right, pause the video, and when you're done, click play. How'd that one go? I'm going to kick things off by checking if it's freezing outside. We'll start there. If the temperature is less than or equal to 32 degrees. Maybe you did less than, not less than or equal to. That's okay. We can go ahead and toss on what we want to do in that case. And all of these are just messages. It's really all we know how to do for the moment. So console.log, it is freezing outside. Excellent. Now down below, we want to check something else. We want to check if it's too hot outside, and we're going to be using an else if for that because there's a specific condition we want to set up. If we just set up else, it would run when it's not freezing outside, but we want to specifically check if it's 110 degrees or greater. Right here, else if. We set up our condition, we set up our code block. In that condition, we are going to check if the temperature is greater than or equal to 110 degrees. In that case, console.log, it is hot outside. Excellent. Now we have both of those in place, and what's the last thing we want to do? It's just to have a fallback. If it's not freezing and it's not hot, it must be just fine. Right here, we'll put that. Console.log, a little message, go for it. It is pretty nice out. Excellent. So there we have it. This is all we needed to do to create an if statement that allows us to go down one of 3 paths. It's either freezing, it's too hot, or it's just right. I'm going to save Boolean Advanced and run the program. This time around, I would expect to see that go for it message, since 45 degrees is right in the middle. This condition fails, this code doesn't run. This condition fails, this code doesn't run, we fall back to else. Now let's switch it up to 450 degrees. In that case, I would expect to see it's too hot outside. Over here, that's exactly what we get. And that's because this condition fails, this code doesn't run. This condition passes, this code runs, and then we stop looking at the rest of the if-else clauses. Next up, a freezing temperature. Let's go ahead and use 4. In this case, we can run the script and make sure we get the correct result, and we do. It's freezing outside. This condition passes, so we run the code and we stop checking the other conditions down below. So there we have it, a slightly more advanced if statement from what we explored in the past, and this is going to give us a bit more flexibility when creating our JavaScript applications. That's where we're going to stop for this one. I'll see you in the next video. In this video, you're going to learn about logical and or operators. These are going to give us a lot more power and flexibility when we set up our if statements. These logical operators are going to allow us to chain together multiple comparison operators to create a more complex condition. Right now, all of our conditions check just a single thing. Is the account locked? Is the user role an admin? Is the temperature less than or equal to 32 degrees? But there are plenty of situations where we might want to have 2 or more different comparison operators chained together. For example, we might want to check if the user's account is locked and they are an admin. Notice that sentence had two different things we wanted to check. The first one is that the user's account is locked, and the second one is that the user is an admin. In that case, we might tell them they need to contact support since they can't contact their admin. They are the admin. So let's go ahead and figure out exactly why these operators are useful and how they work by going through some examples. Over here, a brand new file, logical-and-or.js. And in here, we're going to start with a single input, something we've explored before, a temperature. Let temp equal, and we're going to pick a temp like 65 degrees. For this example, let's say we're trying to alert the user when it's really nice out, and we're going to quantify really nice out as between 60 and 90 degrees Fahrenheit. Right now, we don't have a good way to get that done. And I specifically said good way because we could hack together a solution. I could say if, and then I could add one of the two conditions in here, if the temperature is greater than or equal to 60. Obviously, the code right here would run for a lot of temperatures where it's not in that range, like 120, for example. So how do we fix that? We add another if statement. If the temperature is less than or equal to 90. Now, in this set of curly braces right here, we're going to be able to add some code that runs when the temperature is in that range. So for 65, is this condition true? Yes. So this code runs. Then we run our other condition. Is 65 less than 90? Yes, it is. So this code runs, and that's where we could say it's really nice out. For a temperature like 120, this condition would still pass, so we would run this code. This condition, though, would fail, so we would never run the code that says it's really nice out. Now, this setup could work, but if we wanted to run some code when it wasn't nice out, we would have to add an else onto here and onto here, and that's going to create code that's really complex and not friendly to work with. So we're going to scratch all of that and figure out how we can do this with a single if statement and the logical and operator. Down below, let's set up that if statement. If our condition, our code block to execute when the condition passes. Now let's set up the condition right here. We're going to start off with the first comparison operator we had. We checked if the temperature was greater than or equal to 60 degrees. Now with the logical and or operators, we have something on the left-hand side and we have something on the right-hand side. The symbol for the operator goes in the middle. The symbol for the logical and operator is 2 ampersands. That is Shift 7 on your keyboard, just like this. So we have the left-hand side, we have the logical and operator, and now we're going to set up the right-hand side, which would be the other check we had. If the temperature is less than or equal to 90. Now, down here, we can run some code, and this code is only going to execute if we're in that range. So console.log, it is pretty nice out. Before we explore exactly how this AND operator works, let's go ahead and just run the program. I'm going to save the file in its current state. With a temperature of 65, I would expect the message to print node logical and or.js, and the message does indeed print. If I switched this up to something like 55, I would expect the message to not print. And if I rerun the script, that's exactly what we get. So let's figure out exactly what's going on right here. The logical AND operator has a Boolean on both sides of it. So over here, we know this resolves to a Boolean. The temperature is either greater than or equal to 60 or it's not. And we know this resolves to a Boolean. The temperature is either less than or equal to 90 or it's not. So in the end of the day, the logical AND operator has a Boolean on both sides. If both sides have a Boolean value of true, the whole thing resolves to true. The condition passes and the code runs. If either side has a value of false, then the whole thing resolves to false and the code doesn't run. So imagine I was giving some instructions to my child. You need to eat your vegetables and clean your room if you want to watch TV. It's not enough to just do one of those. Based off of the way I said that, you have to do both. You have to eat your vegetables and you have to clean your room if you're going to watch TV. If you do one and not the other, that's not enough. And the same thing is true here. If both sides are true, the whole thing is true. Otherwise, it's false. Let's outline that. True if both sides are true. false, otherwise. So in the case of 55, this is indeed true, this is indeed false, and that is why we did not see the message showing up. Now let's explore the logical OR operator. So take that same sentence I said before and just put OR there instead of AND. You can watch TV if you eat your vegetables or you clean your room. So in that case, you only have to do one of the things in order to get the result you want. So we can go ahead and break that out with another example. Let's say we want to print a message when it's dangerous to go outside. And we will say it's dangerous to go outside if the temperature is less than 0 degrees or it's greater than 120. So we have if, we have our condition, we have the code to run, and we'll just add a little message right here. Console.log, do not go outside. Excellent. So what is the condition going to look like? Well, we're still going to have the two comparison operators. Is the temperature less than or equal to 0 degrees? And the other one would be, is the temperature greater than or equal to 120? What we put in the middle, though, is going to change. Instead of 2 ampersands, it's 2 vertical bars. You can access those by using Shift followed by the key just above the Enter key on your keyboard. Now we're using the logical OR operator, and as long as one of the sides is true, the whole thing resolves to true. So let's play around with this. I am going to save the file in its current state with a temperature of 55. Is this going to be true? No. Is this going to be true? No. Neither side is true, so I would expect the message to not print. Right here, what do I get? I get nothing. Now let's try a temperature like 150 degrees. In that case, is this true? No. Is this true? Yes. As long as one side is true, the whole thing resolves to true and our code runs. We could also have a situation where both sides are true. Not for this example, since there would be no number that's less than 0 and greater than 120, but we'll explore other examples a bit later in the course. Let's go ahead and outline that right here. Logical OR operator. True if at least one side is true, false, otherwise. Now that we have 150 set up, we can save the script. I can run it from the terminal and we get do not go outside showing up. We can also convert these to using if, else if, and else if we wanted to. So for example, I could delete those lines and put else right here. Now we have, if we fall under this range, print this message. Otherwise, let's see if it's a dangerous temperature, print this message. And then I could add something like an else right onto the end to say console.log. And let's just go ahead and say, do what you want. So now we have these 3 situations using logical and logical OR. Let's go ahead and switch back to one of those mediocre temperatures like 55 degrees and run the program just to make sure it works as expected. Right here, what do we get? We get, do what you want. Go outside, don't go outside, who really cares? So in this case, we check these first. If those pass, we run this. Otherwise, we check these. If those pass, we run this. Otherwise, we run this, printing the message that we just saw. So this is something that we're going to be using over and over again, but I do want to make sure that you at least understand the basics by diving into a quick challenge. Down below, let's go ahead and create a challenge area where you're going to need to use the logical AND operator along with the logical OR operator in an if statement similar but not exactly the same as the one up above. Imagine you're creating a restaurant reservation system, and when you make your reservation using this system, you specify for each guest whether or not they're vegan. So if me and my wife were going out to dinner, I could say that she is vegan and I'm not vegan, for example. So in the end of the day, we're going to have 2 Boolean values. Let is guest 1 vegan equal a Boolean, let's say true, and then let is guest 2 vegan, and we'll go ahead and say false. Now, this reservation system is going to print a little message to the hostess who seats you, and it's going to specify what options they should offer up. So let's go ahead and explore some of the different messages that might end up printing. I'm going to type these out in comments. It's going to be your job to set up the conditional logic to actually get them printing. So the first option, are both vegan? If both are vegan, we only want to offer up vegan food. So we can print a message like only offer up vegan dishes. Excellent. Now there are other situations as well. What if we have a situation where at least one guest is vegan? At least one vegan. If at least one is vegan, if I'm vegan and my wife isn't, I want to offer up a little bit of both. We'll offer up some vegan dishes as well as some non-vegan options. And for that situation, we could print a message, make sure to offer up some vegan options. And the last situation would just be else. If they're not both vegan and not one of them is vegan, then that means neither of them are vegan. And in this case, we'll just offer up anything on the menu. Offer up anything on the menu. It's going to be your job to use the logical and or operators to create a three-part if statement. If, else if, and else. Take as much time as you need to get this done and use the code above as an example. You're going to print those three messages and then you're going to test your work. When you have two vegan guests, you should see the first message. In a situation like this, where you have at least one, you should see that second message. And finally, if neither are vegan, you should see the third message. Take a moment to pause the video, knock this one out, test those three situations by running the file 3 different times, and when you're done, you can go ahead and click play. How'd that one go? Hopefully you were able to make some progress on this. I'm going to kick things off with the first situation. Are both vegan? If, right here, our condition, the code to run. In the condition, is guest 1 vegan? These are already Booleans, so I can just type out the variable name. And is guest 2 vegan? And there we go. We set up the conditional logic for that first situation. And we're going to print our little message, console.log. Only offer up vegan dishes. Excellent. Now let's move on to the other situation. Else, if, another condition, another piece of code to run. In this condition, we're going to check if at least one of them is vegan, and we can use the logical or operator to get that done. Right here, is guest 1 vegan? Or is guest 2 vegan? As long as one of them are, we'll print this message, console.log. Make sure to offer up some vegan options. Excellent. The last situation is what comes under the else clause. If both of them aren't vegan and not one of them is vegan, that means neither of them are. And right here, console.log will print the last message. Offer up anything on the menu. Excellent. So here we have it. This was the challenge. Now let's go ahead and actually test that we did it correctly. In this situation, I have one who's a vegan and one who's not, so I should get that second message. If I save the script and rerun it, I get make sure to offer up some vegan options, which is correct. If they're both vegan, I should get that first message. If I rerun the script, offer up only vegan dishes, that is correct. Lastly, if neither of them are vegan, false up above, false down below. In that case, they could eat anything on the menu, including the vegan dishes, and we print the message, offer up anything on the menu. So there we have it. Using the logical and logical or operators, we're able to chain together two comparison operators to create more complex conditional logic. That's where we're going to stop for this one. I'll see you in the next video where we continue exploring the basics of the JavaScript language. In this video, you're going to learn about variable scope in JavaScript. The scope of a variable defines where it's accessible in your program based off of where it was created. So just because we create a variable in one place in our program doesn't mean it's going to be accessible everywhere else in the script. We're actually going to kick off this lesson by exploring a situation where variable scope is going to prevent our application from working as expected, because so far we really haven't run into any issues with scope in JavaScript. So we're going to start off with a broken example, and that's going to segue us right into the rules that surround scope in this language. So let's kick things off by creating a new file in the basics directory. One of the last files we'll be adding in here, scope.js, and we're going to kick things off with a super simple example. Let's go ahead and make a variable called var1, and I'm going to set it equal to the string var1, just to keep things easy to track. Now down below the variable, what we're going to do is make an if statement. So if condition code to run, and in the condition, we are going to type out the Boolean true. So we're creating an if statement that always executes. This isn't particularly useful in a real world program, but for our example, I want to make sure the if statement always runs. So I'm just going to toss true right in there. Inside of the if statement's code block, what we're going to do is use console.log to print out the value of var1 at this point in time. Then we're going to save the file and run the program to see what we get. Over here, I'm going to execute it, node scope.js. When I run this script, what happens? Well, what happens is exactly what you might expect to happen. We print out the value for var1. The value for var1 is the string var1. That is exactly what we see over here. So far, no issues based off of how we might think this program would work. Now we're going to take things a step further. Right here, after console.log, we're going to make var2. Let var2 equal the string var2, and then down below, outside of the if statement, we are going to use console.log to print var2. So if we run through this script, we create var1. This code always runs. We print var1, which we already created. We then create var2. The if statement ends, and we print var2, which we already created. So let's save scope.js and rerun the program from the terminal and see what we get. When I rerun the script, what do we get? We get a JavaScript error. The error is coming from line 8 of scope.js. That is exactly where we console.log var2, right here. And the actual error message is var2 is not defined. So clearly, for some reason, we're not able to access var2 right here on line 8, even though it's defined just 3 lines earlier. Now, we could even take things one step further and see what happens if I add a second console.log of var2 right here inside of the if statement. I'm going to save the program, use clear to clear the terminal output, and then use node scope.js to rerun the script. We get var1 as expected from line 4. We also get var2 from line 6, and we're still getting that error related to the console.log down below. So it's not like we didn't define this variable correctly. We're able to access it, and we have the exact same statement here and here, so why would one work when the other wouldn't? Well, let's go ahead and explore these scoping rules, and this will all make a lot of sense. Up above, I'm going to add a quick note. JavaScript uses lexical scoping. This is sometimes referred to as static scoping, and this is the idea that a variable defined in one part of your program might not be accessible everywhere else in your program, and that's exactly what we're seeing here. The context in which the variable is defined and used comes into play. When we're looking at our program, the thing we want to pay attention to when it comes to scoping is the code blocks in our script. So the only thing we have right now that creates a code block is the if statement. There are other structures in the language that'll also create code blocks, but we'll get to those later. The code block is right here, what we put inside of curly braces. So these 3 lines of code are inside of that code block. Now, how do code blocks play into scope? Well, there are 2 types of scope. The first type we have is global scope, and the second type we have is local scope. So what is global scope? Global scope contains all of the things defined outside of all code blocks. So let's go ahead and use this definition of global scope to analyze our program. Defined outside of all code blocks. The only code block we have is this. What's defined outside of what I have highlighted? var1. So the only global variable we have is var1. We'll talk about exactly what it means to be a global variable in just a second. Now with local scope, we have a different definition. These are things defined inside a code block. So let's go ahead and analyze this program again. we have one code block. What's defined inside of this code block? var2. So var2 would be considered a local variable. Now this creates a scope hierarchy. So let's go ahead and add a few more comments to break down the hierarchy of this little script. And that's going to make it really clear why we can access var1 in the if statement and why we can't access var2 outside of the if statement. So in all of our scripts, as I mentioned, we have a global scope. This is always going to exist. If we go back to our simple examples like hello world, there is no code block here, so we only have a global scope. Now the global scope in this program's case contains just one variable, and I'm just going to list those out in parentheses, var1. If I created a second one, I could add it on right here, but this program just has one. Now on the next line, I'm going to indent 2 spaces, and we are going to talk about the one local scope we have. This local scope has a single variable var2. So this would be the scope diagram for the script we have down below. Here's the one rule that's going to put all of this together. Right here, in a scope, you can access variables defined in that scope or in any parent/ancestor scope. So what does that mean for us in this application? Well, let's go ahead and break things down. We have our local scope. So what variables can we access? We can access any variable defined in this scope, var1, or in any parent ancestor scope. Well, in our little scope tree, the global scope is at the root. It has no parents or ancestors, so there's nothing else. In the global scope, we can only access var1. In the local scope, we can apply the same rules. I can access any variables defined in that scope, var2, or in any parent ancestor scope. In this case, we do have a parent scope. It's the global scope, which means inside of this local scope, we have access to var2 and we have access to var1. So that explains why we can access var1 and var2 right here and why we can't access var2 down below. var2 is not accessible in the global scope because at no point does the global scope define it or does any parent of the global scope define it. Now let's go ahead and make this slightly more complex and take a look at a more real-world global scope, local scope tree. Right here, we're just going to add another if statement into the mix. If true, and then we're going to define a third variable. Let var3 equal the string var3, and with this program in place, we can now adjust the scope tree. Alongside of our existing local scope, we're going to add another local scope for our new code block. What's defined inside of that code block? Well, right here, we just have var3. So now we have 3 scopes. Global scope can still only access var1. This local scope can still only access var1 and var2. The new local scope can only access var1 and var3. You'll notice that these local scopes are not sharing their variable values. This is not a child of this. They are siblings. They're at the same level. Both of them have a single parent, the global scope. That is why the only thing each of these can access is either their own variable or something defined in the global scope. Let's add just one more if statement into the mix. Right here, in my if statement, I'm going to add another if statement. If true, and then I'll say let var4 equal var4. Now, what might this look like? Well, we can see that by adjusting the scope tree above. Now, nested in this local scope, we have a new local scope. So right here, I'm going to add a new line. I'm going to indent by 2 to visualize this tree structure. A new local scope. What do we have defined inside of there? var4. Now, this local scope has access to var4 and anything defined in a parent or ancestor, which is var2 and var1. This is something a little more real world, like the programs that we're going to actually be creating. Don't worry about memorizing every single rule of scoping just yet. It is important to know, though, that there are rules surrounding it. When you create a program, the context in which you define and use variables plays an important role in whether or not they're actually accessible. I have a couple of more things to say about scope, and I also have some scope-based challenges for you, but we're going to go ahead and do that in the next video. The topic of scope can be a little dense, so I'm going to break this up into two parts. This was part one, where we explored some of the basic vocab and rules surrounding scope. In the next one, we're going to take a look at a couple of edge cases related to it, and it'll be your job to generate some scope trees for some sample programs that I provide. I'm real excited to get to that, so let's go ahead and jump right into the next one. In this video, we're going to finish up our discussion on scope inside of JavaScript. It's a really important topic, so I've broken this up into two videos. I want to make sure you understand the basics of scope before we continue on, because everything else we learn in the language, things we'll cover later like loops and functions, all of those things, like the if statement, are also going to create new code blocks. So scope is only going to become more and more important as we create more and more real-world applications. So it's best to understand the basics now when things are relatively simple, and then we'll continue to see how these same rules get applied later when our programs get more complex. For the moment, though, there are just a couple of edge cases related to what we talked about in the last video that I do want to discuss in this video. So we're going to go ahead and do just that. I'm going to kick things off by creating a brand new file. I'm going to call this one scope2 for scope part 2. That's scope2.js. And we're going to start off with an example similar but not quite equal to what we did in the last one. To kick things off, let's go ahead and create an if statement with a condition of true. And I'm going to take this whole thing and copy it to the clipboard and paste it once inside of itself and then once down below, creating the same scope tree we had in the last video. So we have global, then we have local. In that local, we have another local. And then we have the sibling local down below. So this scope tree, exactly the same as this scope tree because our code blocks match up with these code blocks. Now we already know that I can reference a variable from the global scope in a local scope. Right here, for example, I can say let name equal Andrew, and then down here I can use console.log name. We can then fill out our scope tree, setting name up in the global namespace. And remember, this is just documentation. This doesn't affect the program in any way whatsoever. And what's going to happen? Well, we're going to get to this line. It's going to look for it in the local scope. It's not going to find it. It's going to go up. It's not going to find it. It's going to go up to the root. It's going to find it. It's going to print the value. We already know that. That's not the interesting part. What I want to talk about is the fact that when we have different scopes, we can define variables with the same name in each scope. So in the variables.js file, one of the first rules was you can't define a variable more than once. And that was true. I tried to define pet name twice, but I wasn't able to do that. If I did want to change the value, I just reassigned it by leaving let off. Well, that's because we were trying to define a variable more than once in the same scope. If it's in a different scope, that's okay. So right here, I could say let name equal Mike. Now we can go ahead and adjust the scope tree, putting name right here, and we can simulate what's going to happen. When we get to this line, it's going to look for name. It's not going to find it in the local scope, so it's going to go up to the parent. It's going to look for it there. It is going to find it, and it's going to use that value. This program is going to print Mike. It's not going to crash. It's not going to print Andrew. Let's prove that by rerunning it. Over here, node scope2.js. When I run it, what do I get? I get Mike showing up. This is known as variable shadowing in JavaScript. It's when a variable in a local scope uses its value instead of a variable in a parent scope. So the local variable's value is shadowing over the parent's, basically hiding it from existence. So if I reference name here, I'm always going to get this value for name. I'm never going to end up getting the value for name in that parent scope. So that's variable shadowing, and it's important to know because if you don't know about that, you might think it's illegal to define two names like this. That's not the case as long as they are in different scopes, which is indeed true. Let's take this little example one step further to really drive this point home down below, console.log name again. This time around, this is still going to print Mike. We haven't changed anything up here. What's going to happen with this one though? Well, it's going to look in local right here for name. Does it exist? No. So what does it do? It doesn't go to this. It doesn't go to this. It only can go up the tree to the parent. Does the parent have name? Yes. What's name's value? It's Andrew. So in this case, we're going to get Mike here and we're going to get Andrew here. If I rerun the script with the up arrow key and enter, that's exactly what we get. We still get Mike unchanged and we get Andrew printing down below. Scope comes into play in a lot of different situations. This is just another one. So that's the first half of this video, talking about variable shadowing. What I want to talk about now is what happens when we assign a value to a variable. Right here, before I log out name, I'm going to change name. So I'm going to set name equal to Jen. So what's going to happen with this program? Well, just like when we read a variable's value, when we write a value, we start by looking for that variable in the local scope. Is there a local name whose value we can reassign? And the answer is no, there is no name right here. So what do? We keep going from parent to parent to parent all the way to the root, looking for the first instance of name. We find it in the very next step. We go up to the parent, we find name, that's this one right here, and we reassign its value. So this line is changing name from Mike to Jen. At no point in time are we assigning a new value to this one up above. It stops as soon as it finds the first instance right here. That means if we save this program and rerun it, I would expect to see the changed name here. It should show Jen. And I would expect to see the unchanged name here, which should show Andrew. If I rerun it, I get Jen, I get Andrew. Everything is working correctly. So it's important to note that when you are assigning variable values, it's just as important to take scope into consideration. All right, there's just one more thing I want to discuss. To visualize what I want to talk about, we are going to comment out this variable declaration and this variable declaration. Then we're going to remove name from here and here. And you'll notice that in this file, I'm actually never declaring any variables. There's not a single usage of let that's not hidden behind comments. So let's go ahead and run the program and see what happens. I'm going to rerun the script. And what do we get? We get Jen for both. So this is probably not the behavior we were expecting, but let's go ahead and analyze why this is what's happening. So we have exactly 0 variables declared. So the tree does look like this. But when we run this line, what it's going to do is it's going to look in the local scope for name. It's not going to find it. It's going to look in the parent scope for it. It's not going to find it. It's going to look in that parent's scope. It's not going to find it. When it gets to the root, if it hasn't found it, it declares it. And this is a big problem. So that means that when we assign a new value to name right here, we're actually creating a new global up above. And that might not be clear because there's no usage of let anywhere in the program. This is referred to as a leaked global, when we assign a value to a variable, but that variable was never explicitly defined. So in this case, we have a new global name. That's why it prints here, and that's why it prints here. How do we avoid leaked globals? Well, we just go ahead and actually declare the variable somewhere. We could declare it in this scope. Maybe we want it in the global scope, or maybe we just want it right here. So let name, for example. Now we have a local variable name, which would show up here. That means we'll still get Jen here, and we won't get Jen down below. This is going to create a program, well, still fails, at least fails for a reason we can wrap our heads around. So always make sure that you use let to create a variable if you're going to be using it throughout your program. If you try to assign values to variables you never defined, you're going to get into a situation where your code doesn't work as expected. If I save the file and rerun it, we get Jen printing once, and then we get our error, name is not defined. And this is probably what we expected the first time around, but without let, we never bound name to any specific scope, so it created it in the global scope. All right, that's it for this video, and that is it for this section. Now, I know the last couple of videos were a bit theoretical. We didn't learn a new syntax for the language, we just learned a bit more about how what we're already doing works, and this is important. It's important to understand what happens behind the scenes. And you are going to get a little hands-on experience with Scope in the next section. There's going to be a few challenges where I'm going to give you a program I wrote, and you're going to have to generate the scope tree and figure out what's going to happen. So keep all of these rules in mind, but don't stress about memorizing every little detail. We're going to talk about scope over and over again, and I promise you these will become second nature in no time. Now, what did we learn in this section? Well, when we started, we knew nothing. We learned all about variables, strings, booleans, numbers. We learned about flow control, how to control the flow in our application using if statements, so we can run one block of code and not another block of code. You also learned about those comparison operators and our logical and or operators, allowing us to set up more complex real-world conditional checks. We're going to continue building on our JavaScript knowledge in the next section by talking about functions and objects, two core features to the language, and that's what's going to take us from creating things that feel more like little scripts to things that feel more like actual programs. I'm really excited to get to that, so let's go ahead and jump into the next video, which is the section introduction. I'll see you then. Welcome to section 4. In this section, you're going to learn about functions in JavaScript. When we create a function, we're creating a little program in our program. We can execute that little sub-program as many times as we like. So let's explore why that might be useful. Remember when we created that temperature converter in the last section? We had a temperature starting off in Fahrenheit and we converted it to its counterpart in Celsius and Kelvin. Now that was just a single temperature. Imagine we were given a data set with all of the average temperatures for last year, so 365 temperatures. How would we go about converting all of those from one format to another? Well, we would actually need to write out that code, the conversion code, 365 times, one time for each piece of data we want to convert. When we create a function, though, we can create a little sub-program that handles that conversion for us. So we create this function a single time, and we call it, execute it, as many times as we need to. That's going to allow us to create reusable code, and it's also going to allow us to do some awesome stuff with JavaScript in the browser. For example, if I want to do something when someone clicks a button on the screen, I have to create this little function, this little sub-program that defines what exactly I'd like to do. So functions are essential for modern JavaScript. We're going to be using them throughout the entire course in almost every single video. So let's go ahead and jump right in and see what functions are all about. All right, let's start learning about functions. Before we do, we're going to create a new folder where we can put all of our function-related files, as the basics directory is getting a little crowded. I'm actually going to switch the folder that I have open in the Visual Studio Code editor. I'm going to open from the desktop my JS Bootcamp folder directly. Then, alongside of basics, I'm going to make a new directory, and I'm going to call this one functions. And in here, we're going to create our very first file, and we can just call this one functions101.js. Excellent. Let's also go ahead and switch the directory we're running our commands from. I'm going to use cd ... to go up a folder into the JS Bootcamp directory, then /functions to end up in the functions folder, and then I'll just use clear to clear the terminal output. So, as I mentioned in the intro, functions are little sub-programs. It's a little bit of code we can run over and over again. And there are three important parts to a function. Right here we have the function, we have the function input, we have the actual code to run. So what are we trying to do? Are we trying to convert a temperature, fetch a user, print a message? And we have the output. We're going to ignore the input and the output for the moment, and we're just going to focus on creating our first function, a function that runs some code. We're going to do that right down below. We're going to use let like we would if we were to make a string, number, or boolean. Let greet user, that's what I'm going to call this function, and I'm going to set it equal to, and this is where we have to use the function syntax. So much like the if statement, there is a specific set of rules around defining a function. We have to follow those. The first one is to use the function keyword. We literally type out function. The next is to open and close a set of parentheses. We're going to talk about what goes in here later. For now, though, it's perfectly fine to leave it empty. And then we are going to open and close a set of curly braces and hit enter. And there we have it, our very first function. Does it do anything? No, but it is indeed valid. So much like our if statements have a code block where we can put the code we want to run, like for example, right inside of here, our functions also have a code block that creates its own scope, right here. Anything we want to do when the function executes goes right inside of here. For the moment, we're just going to go ahead and use log to print a message. Later on, we'll figure out how to convert a temperature, combine variables, call other functions, or do whatever else we need to do. In here, what are we going to do? We are just going to print a little message to the screen. Welcome, user. Excellent. Now that our function actually does something, we can't run the file just yet. Well, we could run the file, but the function's never going to execute. At this point, we've defined a function. Defining a function would be like defining a JavaScript file. Yes, it exists, but you haven't actually done anything with it. If we want this code to run, when we execute this file, we have to call it. So if I were to execute the script, node functions101.js, what do I get? I don't get an error, I just get nothing. The program didn't run. If I do want to run this little subprogram, I have to call the function. Right here, I execute it by referencing it by name, so greet user. This alone isn't enough. I have to use the function call syntax, which is an opening and closing parenthesis after the name. Now, we'll talk about what goes inside of here a bit later too. For now, it's perfectly fine to leave it empty. If we save the file and rerun things, what do we get? We get welcome user printing to the screen, which is fantastic. We have created and called our very first function, and we can call this function as many times as we see fit in our program. So I could paste that line 2 more times, and what's going to happen if I run the script? I'm going to see our welcome user message 3 times, and that's exactly what I get. With the most basic function accomplished, let's go ahead and create something a little more practical. We are going to introduce the input, the code, which we already have, and the output. For this one, let's say we want to square a number. So what do we take into the function? We take in the number we want to square. What does the code do? The code squares the number. What's the output? The output would be the squared number. So if I passed in 3, the code would multiply 3 times 3, and the output would be 9. Let's go ahead and see that in practice down below. I'm going to use let to create square. I'm going to set it equal to a function, so we use the function keyword. We open and close our parentheses, and we open and close our code block using curly braces. Down below, we can also go ahead and call this before filling it out. Square. And I'm going to pass in a number. Now, how do we pass a number into a function? Well, we do this by providing what's known as an argument. So the input, in terms of how the vocab works for JavaScript, it's actually known as an argument or arguments plural. So if you read a blog post on a function, you're not going to see input thrown around. You're going to see argument. So if we want to pass an argument into square, the value to square, how do we do that? Well, we provide it right here between the parentheses. So if I wanted to provide a number, I could literally just put a number right here. I could say 3, for example, or I could reference a variable that stores the number. So I could have a variable up above, let num equal 3, and then I could reference that variable instead of just putting 3 right in there. Both of those have the exact same effect, and for simplicity's sake, I'm just going to stick with passing in 3 right there. Let's go ahead and delete this line completely, and we're back to where we started. So at this point, we are passing in a single argument to square. We're passing in the number 3. The question is, how do we actually get access to this value inside of the function code? Well, we do that by naming the value right here in the parentheses for the function definition. So much like we would name a variable, we go ahead and name the argument right here. We can call this one num. Let's go ahead and actually do something with num to make sure the value is getting passed in correctly. Right here, console.log, I'm just going to print out num. We'll focus on squaring the number in just a second. If I save the file and rerun it, I would expect to see welcome user 3 times, and then I would expect to see 3 a single time. Let's go ahead and rerun the file, and that is exactly what we get. Right here, the argument value is getting passed in. we are seeing 3 get passed into the function, and when we print it, what are we getting? We're getting the value. We are getting 3. Now we can add multiple calls to square as well. I could call square right here with 10 if I wanted to, and now if we rerun the script, the first time the function runs, the value will be 3, and the second time the function runs, the value will be 10. Over here, we get 3, we get 10. So this is how we can set up basic input. We'll learn more about passing in multiple values later and what to do if a value isn't passed in. For now, we're going to stick with a more trivial setup. So what do we do from here? We square the number. We focus on the code side of things. We can do that right here. I'm going to call this one result equal, and all I'm going to do is take the number and multiply it by, using the asterisk sign, what? The number. So num times num. Now we have this result. So in the case of 3, it would be 3 times 3, which would be 9. In the case of 10, it would be 100, 10 times 10. So we have the input, our arguments. We have the code that actually does something. The last piece is the output. And the output is also known as the return value. So just like if you read an article on functions, you won't see input, you'll see arguments. You're not going to really see anyone call the function return value the output, but that is an easy way to think about the 3 pieces. It's really called the return value, and that's because to return something, we have to use the return statement. So right here, how do we do that? Well, we type out return. This is a reserved keyword in the language, and it can be used a single time only in your functions. So right here, we can choose to return a single value from this function. What's that value going to be? It's going to be result. So we reference it, result right here. Now we have a function that does all 3 things. It takes in some value as the argument, it uses some code to do something meaningful, and then it returns a value. In this case, it returns the squared value. Now, if we were to run the program in its current state, it wouldn't do anything. We wouldn't see any output related to our second function. Right here, we get 3 instances of welcome user, but we don't get 9 or 100 printing. That's because the return value isn't being used. So let's figure out how to use it, and then we'll move on to a challenge where you'll need to create a function of your own. What I'm going to do right here on line 16 is create a variable. So let value equal, and then on the right-hand side, as the thing to store in value, I'm going to keep the function call. So this is the setup we use to call a function with an argument and then store the return value. So the end result of this is the return value, and here we're just putting it in a variable. We can do the same thing down below for square 10. Let's go ahead and actually do that. Right here, let other value equal, and then what are we going to do? Well, we're going to get the value back from calling square with the number 10. The end result, 100. Now we can actually print both of these to the screen, console.log value. And you'll notice something. Log is indeed a function. We're calling it with some parentheses, and we're passing in an argument. Whatever argument we pass in gets printed to the console. So now we know a little bit about this line. We still don't know what the dot part is and the console up in front, but we can at least break down this piece right here. On the next line, console.log, other value. Then all we're going to do is save the program and see what happens when we run it. I'm going to rerun the script, and this time around we are getting welcome user 3 times. We're then getting the number 9, which is the correct result, and the number 100, also correct. So there we have it. We have a function that has a set of arguments, a number. We got our code, we have our output. When we want to call a function, we reference it by name with some parentheses on the end. In there, we can pass in the input we want to provide to the function. And if we want to do something with the return value, we can just put the function call over here with a variable set up beforehand. Now that we've seen all of this in practice, I want you to create a function on your own as the challenge for this video. So down below, a little challenge area is indeed appropriate. For this challenge, you're going to be creating a function called convert Fahrenheit to Celsius. And as the name suggests, this function is going to take in as the argument the temperature in Fahrenheit. It's then going to run the conversion algorithm, and it's going to return the temperature in Celsius. So after you create the function, you're going to call it. down below, call a couple of times. And if you want some sample values, 32 should get converted to 0. And then another good one would be 68 degrees Fahrenheit, which should get converted to 20 degrees Celsius. Then the last thing you're going to do is print the converted values. So this is very similar to what we just did above. We defined our function. We then called the function a couple of times, and then we did something with the return value. That's exactly what you're going to be doing down below. Define the function, call it, do something with the returned value. If you forget how to convert the temperature, don't worry. You can just use the temp conversion project that you created before. You have the algorithm sitting right up top. If you don't have that file anymore, you can always download it. It's available in the lecture zip for every single lecture. All right, take some time to knock this one out and then go ahead and test your work. When you run the program, you should see 0 and 20 at the bottom, assuming you're using the same two input values I set up right here. Pause the video, and when you're done, click play. How'd that go? Hopefully you were able to get that done without too much trouble. I'm going to kick things off by defining the function up above. I already have the variable name typed out, so I'm just going to remove the two slashes and toss let up front. I'm then going to set this equal to a new function. Got my function keyword, my arguments list, and the code to run. Now there is going to be a single argument for this one. The name you picked isn't particularly important as long as it's meaningful. So maybe you went with temp. I'm going to go ahead and go with Fahrenheit. Next up, we need to actually do the conversion process. I have to get the value in Celsius. We already have that code sitting right over here, so I can actually just take that algorithm, copy it, and paste it right in here. Now, it's important to remember, this algorithm references some variables like Fahrenheit, but that's okay, because we have Fahrenheit defined up above. So we actually don't need to change anything about this line. What's the next thing we want this function to do? We want it to return the converted value. So down below, we can wrap up our function by using return. What are we trying to return? We're trying to return the temperature in Celsius. Now we can move on to the second stage, which is to actually call this a couple of times. So right here, let temp1 equal, and we can go ahead and use our function convert, and you can see that the auto completion is actually picking up on the function that we created. And right here, we can just click that to auto complete it, and then we can pass in the value. I'm going to pass in 32 degrees for the first one. Let's go ahead and duplicate this line. I'm going to go ahead and highlight the whole thing, copy it, and paste it down below. And now what we're going to do is define temp2 for the second call, and we'll change the value. Let's go ahead and change it over to the other sample data I gave you. That was 68. The last thing to do is to print those two values. So console.log temp1, and down below that, console.log passing in temp2. With this in place, we can remove those comments and we can go ahead and test our work. Let's cross our fingers and hope everything works as expected. Right here, I'm going to rerun the script, and the only two values we care about are the last two values, the logs that come from the challenge. Right here, we're getting 0 for the first one, which is correct, and 20 for the second one, also looking good. So there we have it. This was a quick rundown on the basics of functions. Now at this point, you probably still have a ton of questions. For example, can I pass in multiple values? What happens if I call a function and don't pass in the arguments it expects? We're going to get to all of that in this section. At this point, what I wanted to explore is the basic syntax. The fact that when we create a function, we have our arguments, the code, and our return value. We've seen that in a couple of different situations. Let's continue on to the next video and start exploring some of the details. I'm excited to get to that. I'll see you then. That's it for this 2-hour preview of the Modern JavaScript Bootcamp. There is a link in the description down below. There you can view the entire course curriculum and see what fun and interesting projects we end up creating. There you can also read reviews and purchase the entire class. I'm Andrew Mead, and I hope to see you in the course sometime soon.